Creating millions of identical, perfectly curved chips at lightning speed seems impossible, but Pringles factories do it every single day. Using a process unlike any other snack, these chips aren't sliced from potatoes, but engineered from a precise formula to achieve their signature crunch. Today, we take you behind the scenes of the Pringles production line, from dough preparation to frying and packaging. Let's uncover the mind-blowing science behind the world's most famous chips. The manufacturing of Pringles is an intricate process that combines food science, precise engineering, and large-scale automation to produce the uniform, crisp, and stackable potato chips recognized worldwide. Unlike traditional potato chips, which are sliced from whole potatoes and fried, Pringles are created from a specially formulated dough made primarily of dehydrated potato flakes, starches, and seasonings. The process of making Pringles in a factory involves several key stages, each meticulously designed to ensure the final product meets strict quality standards. It all begins with selecting the right raw ingredients, primarily potatoes, which serve as the foundation of the chips. However, not just any potatoes will do. Pringles require specific varieties with the right starch content to achieve the desired texture. High starch potatoes are preferred because they contribute to the crispness of the final chip and help bind the dough together during production. Once the right potatoes are sourced, they are transported in bulk to the factory, where they undergo an initial round of inspection. Before entering the processing phase, the potatoes are stored in climate-controlled environments to maintain their quality. Even small variations in temperature and humidity can affect their starch content, which in turn impacts the final texture of the chip. Workers constantly monitor these storage conditions to ensure that the potatoes remain in an optimal state before processing. When ready for use, the potatoes are moved to the preparation area, where they go through a rigorous washing process. Large industrial washers, equipped with rotating brushes and high-pressure water jets, remove dirt, debris, and any residual pesticides from the potato skins. This step is crucial, as any impurities at this stage could compromise the quality of the final product. The washing process is thorough, ensuring that only the cleanest potatoes make it to the next stage. Once cleaned, the potatoes are sent through a peeling machine, which uses either steam or mechanical abrasion to remove the skins efficiently. Steam peeling is a common method in large-scale food production, as it allows for quick and uniform removal of the skin with minimal waste. The peeled potatoes are then conveyed to slicing machines, but unlike conventional potato chips, where these slices would be fried, the goal here is to break them down into a form that can be processed into a dough. To achieve this, the sliced potatoes are sent through a pre-cooking stage, where they are partially heated to help break down their cellular structure. This step makes it easier to remove moisture later in the process. The pre-cooked potato slices are then transferred to large industrial dryers, where hot air circulates around them, slowly extracting moisture until they are fully dehydrated. What remains after this process is not whole potato slices, but thin, brittle flakes of potato. These dehydrated potato flakes serve as the primary base for Pringles and are stored in large silos within the factory. However, potato flakes alone are not enough to form the distinctive shape and texture of Pringles. Additional ingredients must be added to create the dough that will eventually be shaped into chips. When it is time to begin the production of a batch, the potato flakes are carefully measured and transferred to industrial mixing machines. Inside these massive mixers, the flakes are combined with other ingredients such as cornstarch, wheat starch, emulsifiers, and small amounts of salt and sugar. These additional ingredients help give Pringles their characteristic crunch and structure, while also ensuring that the dough is flexible enough to be shaped without crumbling. Water is then gradually added to the dry mixture, and the entire batch is kneaded until it forms a smooth, pliable dough. This step is one of the most crucial in the entire process, as the consistency of the dough determines how well the chips will hold their shape and how they will fry later in the process. Too much water and the dough will be too soft, making it difficult to handle. Too little and it will become too dry, leading to chips that may crack or break during production. The mixing process is highly automated, with computer-controlled machines ensuring that every batch has the same precise ratio of ingredients. Factories use real-time monitoring systems to adjust the moisture content and consistency of the dough as needed, ensuring uniformity across millions of chips. Any slight variation in dough quality could lead to a final product that does not meet the brand's strict standards, so maintaining precise control over this step is critical. Once the dough reaches the perfect consistency, it is ready to be shaped. However, before this can happen, the dough must be processed into thin sheets. This is accomplished using large industrial rollers, which gradually flatten the dough to an exact thickness. The thickness of the dough sheet is critical, as it determines the final texture and crunch of the Pringles. If the dough is too thick, the chips will be too hard. If it is too thin, they may become fragile and brittle. The flattened dough sheet is then conveyed to a cutting station, where specially designed rotary cutters stamp out individual chip shapes. Unlike traditional potato chips, which take on random forms based on how they are sliced, Pringles are designed to be identical in size and shape. Each cutter is engineered to create the precise oval form that allows the chips to stack perfectly inside their cans. During this process, any excess dough that remains after the chips are stamped out is collected and fed back into the mixing stage. This recycling process minimizes waste and ensures that as much of the raw material as possible is used efficiently. The ability to reuse excess dough is one of the advantages of making Pringles from a formulated dough rather than whole potato slices. At this point, the chips are still in their raw, unbaked form. They have been cut into shape, but they are not yet crispy. To achieve their signature texture, they must go through the next phase of the manufacturing process, where they will be carefully molded and cooked. This is where Pringles truly begin to take on their distinctive identity. Before they can be cooked, the raw chips must be shaped into their famous curved form. This is done using a specialized conveyor system that gently places each chip into a custom mold. These molds are designed to hold the chips in a precise curve, known as a hyperbolic paraboloid, which is what gives Pringles their unique stacking ability. The shape is not just for aesthetics. It also helps distribute weight evenly when the chips are stacked in their can, preventing them from breaking easily. Once placed in the molds, the chips are conveyed toward the cooking stage, where they will be exposed to controlled heat and oil. This step is critical in achieving the crispy, golden brown texture that Pringles are known for. However, unlike traditional potato chips, which are deep fried in vats of hot oil, Pringles are cooked in a specialized method that ensures even frying while maintaining their precise shape. At this point, the chips are not yet fully cooked, nor have they been seasoned. The next phase will involve exposing them to heat and oil, followed by a careful seasoning process that gives each chip its final flavor. But before that happens, factory workers and automated quality control systems continuously monitor the process to ensure that each chip is perfectly shaped and free of defects. With the raw dough pieces now cut into their precise, uniform shapes and carefully placed into their curved molds, they are ready to undergo the critical cooking process. This step is what transforms the soft, pliable dough into the crisp, golden brown chips that Pringles are known for. Unlike traditional potato chips that are submerged in deep vats of hot oil and fried freely, Pringles undergo a much more controlled cooking method to maintain their exact shape and texture. The chips, still nestled in their curved molds, travel along a continuous conveyor belt into an industrial fryer. This fryer is designed to ensure that each chip is cooked at an exact temperature for a precise amount of time. The temperature inside the fryer is meticulously controlled, typically ranging between 300 degrees Fahrenheit and 375 degrees Fahrenheit, depending on the specific requirements of the batch being produced. The goal is to remove moisture from the chips without overcooking them, achieving the perfect crunch while preserving the uniform shape. The frying process takes only a matter of seconds, but within that short time, several crucial chemical reactions occur. The high heat causes the remaining water content inside the dough to rapidly evaporate, creating tiny air pockets that give Pringles their distinctive lightness. At the same time, the starches and sugars in the dough undergo the Maillard reaction, a chemical process that causes browning and enhances the chip's flavor by developing rich, slightly nutty, and toasted notes. Because the chips are fried in a controlled environment while sitting inside their molds, they do not curl or warp the way traditional potato chips do. Instead, they maintain their signature hyperbolic paraboloid shape, which is key to their ability to be stacked efficiently without breaking. To ensure even cooking, the oil circulates through the fryer using a sophisticated system that maintains uniform heat distribution, preventing any chip from becoming overcooked or undercooked. Once the chips have been fried to perfection, they must be quickly removed from the hot oil to prevent excessive absorption of fat, which could compromise their texture and make them overly greasy. The chips exit the fryer onto a draining conveyor, where excess oil is gently shaken off. A series of air jets then blow away any remaining oil droplets, ensuring that each chip has the right balance of crispness without being overly oily. The amount of oil that remains in the final product is carefully monitored, as even a small deviation in fat content could alter the texture and mouthfeel of the chips. After the excess oil is removed, the chips continue along the conveyor system into a specialized drying chamber. This drying stage serves a dual purpose. It helps eliminate any remaining moisture to extend the shelf life of the chips and ensures that they retain their crisp texture. If any residual moisture remains, it could lead to sogginess or even microbial growth, which would compromise the quality of the product. The drying chamber operates using a controlled flow of warm air, which gently removes any lingering humidity without exposing the chips to excessive heat. This is a crucial step because overdrying could make the chips too brittle, leading to breakage before they even reach the packaging stage. The process must strike a balance between removing moisture while preserving the ideal crunch. Now that the chips have been properly fried and dried, they still lack one essential component: flavor. While the dough contains some base seasonings, such as salt, the majority of Pringles' signature flavors are added after cooking. At this point, the chips are still relatively plain, resembling lightly salted potato crisps. To give them their final taste, they must go through the seasoning process. The chips enter a large rotating drum, which is a key part of the flavoring system. This drum functions much like a giant tumbler, gently tossing the chips to ensure that each one is evenly coated with seasoning. However, before the seasoning can be applied, the chips must be lightly misted with a fine spray of oil. This thin coating of oil acts as an adhesive, allowing the seasoning to stick uniformly to each chip without clumping. Once the oil mist has been applied, the chips move further into the drum, where a precise amount of seasoning powder is dispensed. This powder is a proprietary blend of dehydrated spices, artificial and natural flavors, and other ingredients that create the distinct taste of each Pringles variety. Whether it's the classic original, sour cream and onion, barbecue, or any of the many other flavors available around the world, each seasoning mix is carefully crafted to deliver a consistent and recognizable taste. The rotation of the drum ensures that the seasoning is distributed evenly across all chips, preventing any one chip from receiving too much or too little flavor. This is crucial because even slight inconsistencies in seasoning distribution can affect the overall eating experience. Too much seasoning on one chip could make it overpowering, while too little could make it bland. The factory's precision-engineered system ensures that every chip in a can has the same delicious taste. To confirm that the seasoning has been applied correctly, automated sensors monitor the amount of seasoning powder dispensed and the overall coating level. These sensors use advanced optical and weight measurement technologies to detect any irregularities in the seasoning process. If an issue is detected, such as an uneven application or a deviation from the standard amount of seasoning, the system can automatically adjust to correct the problem in real time. Now fully seasoned, the chips continue their journey toward the final stages of production. At this point, they must be carefully handled to prevent breakage before they are packaged. Despite their sturdy design, Pringles are still delicate enough to crack if handled too roughly, so the conveyor system is designed to gently transport them through the factory. Before reaching the packaging area, the chips pass through another quality control checkpoint. High-speed cameras and sensors inspect each chip to ensure that they meet the brand's strict standards. Any chips that are overly browned, misshapen, or broken are automatically removed from the line. These rejected chips do not go to waste. They are often ground down and repurposed as part of the raw ingredient mixture for new batches, minimizing food waste in the production process. Now, with their perfect shape, crisp texture, and flavorful coating, the chips are ready for packaging. However, the packaging process itself is an essential part of what makes Pringles so unique. Unlike traditional potato chips, which are packed into bags that allow for some degree of breakage, Pringles are carefully stacked inside rigid cylindrical cans. This design ensures that they remain intact from the moment they leave the factory to the time they are opened by consumers. As the chips approach the packaging area, specialized machines align them into precise stacks. These machines use gentle vibrations and suction mechanisms to ensure that each stack is perfectly arranged before being inserted into the canisters. The stacking process is incredibly precise. Any misalignment could cause the chips to break during transportation. At this point, the Pringles are nearly ready to be sealed and sent out for distribution, but there are still a few final steps left to complete before they can reach store shelves. The packaging must ensure freshness, provide product protection, and meet branding and labeling requirements. In the next stage, the stacked chips will be inserted into cans, sealed for freshness, and prepared for shipment. With the freshly seasoned chips perfectly stacked and aligned, the Pringles are now ready for the crucial packaging stage. This process is just as important as the manufacturing and cooking steps, as it ensures that the chips remain intact and fresh until they reach consumers. Unlike traditional potato chips, which are packed loosely in bags that allow for some level of breakage, Pringles are carefully placed into rigid cylindrical cans, a signature feature that sets them apart from other snack foods. The packaging process begins with the automatic loading of the Pringles stacks into their respective canisters. These canisters, made from a combination of cardboard and aluminum lining, are designed to provide structural support, protecting the delicate chips from breaking during transport. The cans arrive at the packaging station in a flattened state and are quickly formed into their cylindrical shape by specialized machinery. The inner lining of the cans is coated with a food-safe aluminum layer, which helps to preserve freshness by preventing exposure to moisture and air. Once the cans are fully formed, they are transported to the filling station, where the Pringles stacks are precisely inserted into them. This process requires extreme precision, as any misalignment could cause the chips to shift or break. A combination of gentle vibrations and suction mechanisms ensures that the stacks remain stable as they are guided into the canisters. If even a single chip in the stack is out of place, the entire batch may be rejected to maintain quality standards. As the filled cans move along the conveyor, they reach the sealing station, where a thin foil seal is applied to the top of each canister. This foil seal serves multiple purposes. It locks in freshness, prevents air from entering, and ensures that the chips remain crisp for an extended period. The application of the seal is a highly controlled process that uses a combination of heat and pressure to create an airtight bond between the foil and the can's rim. Automated sensors continuously monitor the sealing process, detecting any imperfections or leaks. If a faulty seal is identified, the can is removed from the production line and either reprocessed or discarded. After the foil seal is in place, a plastic lid is applied to the top of the can. This lid serves as a secondary protective barrier and allows consumers to reseal the container after opening. The lids are typically made from lightweight but durable plastic that ensures a secure fit while remaining easy to remove. Before being placed onto the cans, the lids are inspected for defects, such as warping or cracks, which could compromise the product's freshness. With the Pringles cans now fully assembled and sealed, they move toward the labeling and branding station. Here, pre-printed labels featuring the Pringles logo, flavor designation, and nutritional information are carefully wrapped around each canister. These labels are made from high-quality materials that are resistant to moisture and tearing, ensuring that they remain intact throughout the product's journey from the factory to store shelves. A combination of heat and adhesive is used to secure the labels in place, ensuring a smooth, wrinkle-free application. Once labeled, the finished cans undergo another round of quality control checks. Automated cameras and sensors scan each can to verify that the labels are correctly applied and free of defects. Any cans with misaligned or damaged labels are removed from the line and either relabeled or discarded. Additionally, random samples from each batch are taken for more detailed inspections, where factory workers check for overall product integrity, including stack alignment, sealing effectiveness, and crispness. After passing the final quality control checks, the Pringles cans are grouped together for bulk packaging. This step involves placing multiple cans into larger cardboard cartons or shrink-wrapped bundles, which make transportation and stocking more efficient. The bulk packaging process is automated, with robotic arms carefully arranging the cans into pre-formed boxes or wrapping them in durable plastic film. The goal is to maximize space efficiency while ensuring that the cans are securely held in place to prevent movement during shipping. Once the bulk packaging is complete, the cartons are sealed and labeled with batch numbers, expiration dates, and tracking information. These labels allow for easy inventory management and ensure that products can be traced back to their specific production batch if necessary. The cartons are then stacked onto pallets, which are loaded onto trucks for distribution to retailers, supermarkets, and convenience stores around the world. Before being shipped out, the finished products undergo a final inspection to verify that the correct quantities and flavors have been packed for each order. Logistics teams coordinate with distribution centers to determine the most efficient shipping routes, ensuring that Pringles reach their destinations as quickly and cost-effectively as possible. Since Pringles are a globally recognized brand, this distribution network spans multiple countries, requiring careful coordination between factories, warehouses, and retailers. Throughout this entire process, Pringles manufacturers adhere to strict hygiene and safety regulations to ensure product quality and consumer safety. Factory workers follow rigorous sanitation protocols, wearing protective gear such as gloves, hairnets, and face masks to prevent contamination. The production facilities are regularly inspected by quality assurance teams and food safety organizations to ensure compliance with industry standards. In addition to maintaining high production standards, Pringles manufacturers are constantly exploring ways to improve sustainability and reduce waste. the company has implemented initiatives to minimize environmental impact, such as optimizing energy usage in production plants, recycling excess packaging materials, and reducing food waste by repurposing rejected chips and excess dough. In some regions, Pringles packaging has been redesigned to use more eco-friendly materials, with ongoing efforts to further enhance the sustainability of the product. While the cans of Pringles are now ready to be shipped to stores, the journey does not end there. Once they arrive at retail locations, they must be carefully stocked to ensure they remain in pristine condition for customers. Store employees follow specific stocking guidelines to prevent the cans from being crushed or stacked improperly. The cylindrical shape of the canisters allows them to be displayed neatly on shelves, creating an organized and visually appealing presentation. For consumers, the convenience of Pringles packaging is one of its most attractive features. The resealable lid allows snackers to enjoy the chips at their own pace while keeping them fresh between servings. Unlike traditional chip bags that often trap excess air and lead to crushed chips, the rigid canister provides a level of protection that helps maintain the product's quality. The success of Pringles is not only due to the meticulous manufacturing process, but also to the brand's ability to continually innovate. Over the years, new flavors and limited edition varieties have been introduced to cater to different tastes and cultural preferences. Research and development teams work to create unique seasoning blends and textures that keep consumers engaged with the brand. In some cases, local flavors are developed exclusively for specific markets, adding an element of regional customization. With the fully sealed and labeled Pringles cans ready for shipment, the final step in the manufacturing process involves distribution and logistics. Once the pallets of Pringles leave the factory, they are sent to distribution centers where they are sorted based on destination. From here, they are shipped to retail locations around the world, including supermarkets, convenience stores, vending machines, and online retailers. One of the key advantages of Pringles' packaging is its durability. Unlike traditional potato chips that are shipped in large bags, prone to air compression and breakage, Pringles' rigid canisters allow for efficient stacking and transport without excessive damage. This means fewer chips are wasted due to breakage during shipping, making the product more cost-effective and reducing food waste. At the retail level, Pringles cans are often displayed in neat, vertical arrangements on shelves, taking advantage of their cylindrical shape. This design not only protects the chips, but also maximizes shelf space compared to bulky chip bags. Supermarkets and convenience stores follow specific stocking guidelines to ensure that Pringles cans remain undamaged and easily accessible to customers. Once purchased, consumers benefit from the resealable can, which keeps the chips fresh longer than traditional bags. Unlike conventional chip bags that often allow air to seep in after opening, leading to stale chips, Pringles' airtight design helps maintain their signature crunch over multiple servings. This has been a significant selling point for the brand and one of the reasons for its continued popularity. Beyond the production process, the Pringles brand continues to evolve. The company regularly develops new flavors, incorporating regional tastes and limited edition releases to cater to different markets. Flavors such as wasabi, pizza, and even dessert-inspired varieties have been introduced over the years, keeping the brand relevant and exciting for consumers. In recent years, sustainability has become a growing concern, leading to efforts to improve the recyclability of Pringles packaging. While the multi-material composition of the can presents challenges for recycling, Pringles manufacturers are exploring alternative packaging solutions that reduce environmental impact while maintaining product integrity. As technology advances, the future of Pringles manufacturing may include even greater automation, improved energy efficiency, and smarter quality control systems. artificial intelligence and machine learning could further refine production, ensuring even higher consistency in shape, flavor, and texture. Additionally, new ingredients and production techniques could be developed to create healthier or more sustainable variations of Pringles. The journey of a Lay's potato chip begins long before it reaches the factory. It starts in carefully selected farms, where high-quality potatoes are cultivated under strict agricultural standards. Lay's manufacturers work closely with farmers to ensure that only the best potato varieties are used, focusing on those with the right balance of starch and moisture. This is crucial because the composition of the potato determines how well it crisps during frying and how it absorbs seasoning. The selected varieties are chosen for their ability to produce a light, crunchy texture while maintaining the signature taste that has made Lay's a household name. The potatoes are grown in rich, fertile soil, monitored throughout the growing season to ensure optimal size, shape, and starch content. Farmers pay close attention to irrigation, pest control, and harvesting schedules to meet the brand's high standards. When the potatoes reach the perfect stage of maturity, they are harvested using specialized machinery designed to minimize bruising and damage. The harvested potatoes are loaded into large trucks and transported to Lay's production facilities, where the real transformation begins. Upon arrival at the factory, the potatoes undergo an initial inspection to check for quality, size, and any visible defects. Automated sorting machines and human inspectors work together to identify and remove any potatoes that do not meet the necessary standards. The goal is to ensure that every potato entering the production line will contribute to the consistent, high-quality chips that consumers expect. The selected potatoes are then stored in climate-controlled environments to maintain their freshness until they are ready to be processed. Before they can be turned into chips, the potatoes must be thoroughly cleaned. They pass through high-powered washing systems that remove dirt, pesticides, and any residual soil from the harvesting process. This step is crucial, as even tiny impurities could affect the taste and texture of the final product. The cleaning process uses jets of water and rotating brushes that scrub the potatoes without damaging their structure. After washing, the potatoes move along a conveyor belt toward the peeling station. Peeling is an essential step in ensuring a smooth and uniform surface for slicing. Large industrial peeling machines use abrasion or steam to remove the skin efficiently while preserving as much of the potato as possible. The peeling method used depends on the specific facility, but both techniques are designed to be fast and effective, ensuring that the potatoes retain their natural integrity. Any residual skin is removed by high-pressure water sprays before the potatoes move to the next phase of production. With the potatoes now clean and peeled, they are ready for slicing. The slicing process is one of the most critical steps in determining the texture and crispness of the final chip. The potatoes are fed into high-speed rotary slicers equipped with precision-engineered blades. These blades cut the potatoes into uniformly thin slices, ensuring that each chip cooks evenly. The thickness of the slices varies depending on the type of Lay's chip being produced, whether it's classic, wavy, or kettle cooked. The precision of the slicing process is carefully monitored, as even slight variations in thickness can affect the frying process and overall quality. Once sliced, the potato pieces undergo another quick rinse to remove excess surface starch. This helps prevent the chips from sticking together during frying and contributes to the signature crisp texture. The slices then move through an automated dewatering system, where excess moisture is removed before they enter the frying stage. Proper moisture removal is essential, as too much water content could interfere with the frying process and create inconsistencies in texture. At this point, the sliced and dried potatoes are prepared for frying. The frying process is meticulously controlled to ensure that every chip reaches the perfect level of crispness. Conveyor belts carry the slices toward massive industrial fryers filled with hot oil. The oil temperature is carefully maintained to ensure consistent cooking, and the frying time is precisely measured to achieve the ideal golden brown color. The type of oil used varies depending on the region and product line, but it is always selected for its ability to enhance the flavor and texture of the chips while meeting health and safety standards. As the potato slices enter the fryer, they begin to bubble and sizzle, their moisture rapidly evaporating as they absorb just the right amount of oil. This transformation is what gives Lay's chips their signature crunch. The frying process is closely monitored by sensors and quality control specialists, ensuring that each batch meets the company's strict standards. The duration of frying varies depending on the type of chip, but every second counts in achieving the perfect crispness. The chips continue their journey along the production line, still hot from the fryer. At this stage, they are carefully drained of excess oil using advanced drying techniques. This step is crucial, as too much residual oil could make the chips greasy, while too little could impact their mouthfeel. A fine balance must be maintained to ensure that each chip retains the light, crispy texture that Lay's is known for. With the chips now cooked to perfection, they move forward to the seasoning stage, where their flavor truly comes to life. Lay's offers a wide variety of flavors, from the classic lightly salted to bold, complex seasonings that cater to different tastes and preferences. Each flavor blend is created using a combination of spices, herbs, and other ingredients that have been meticulously tested for balance and intensity. The seasoning process is highly specialized to ensure even distribution, guaranteeing that every chip is coated with the perfect amount of flavor. Before seasoning is applied, the chips pass through a gentle tumbling system that helps prepare them for even coating. This ensures that every chip has an optimal surface for seasoning adherence. A light mist of oil may be added at this stage to help the seasoning stick, ensuring that every bite delivers the intended flavor experience. The seasoning is then evenly sprinkled over the chips using automated dispensers that precisely measure the amount applied. Quality control specialists continuously test and monitor the seasoning levels, ensuring that each batch is consistent. Lay's has developed advanced flavoring systems that use real-time feedback to adjust the seasoning application as needed. This ensures that no chip is under-seasoned or over-seasoned, preserving the product's signature taste. Once the chips have been seasoned to perfection, they continue moving along the production line toward the next stage of the process. The chips must be handled carefully to prevent breakage and ensure they retain their structure as they progress through the factory. The journey is far from over, with several more key steps left before they are ready for packaging and distribution. As the freshly seasoned chips continue moving through the production line, they enter one of the most critical stages of the entire process: quality control. Lay's has built its reputation on delivering chips that are consistent in taste, texture, and appearance. And this is only possible through rigorous inspections at multiple points along the manufacturing process. Each chip must meet exacting standards before it is deemed fit for packaging, so quality control systems are an integral part of the factory's operation. The first stage of quality control involves high-speed cameras and sensors that scan the chips as they pass along the conveyor belt. These cameras are equipped with advanced imaging technology that detects any chips that are misshapen, burnt, undercooked, or broken. If a chip does not meet the specified criteria, it is automatically removed from the production line using precision air jets that quickly and efficiently separate defective chips from the rest. This ensures that only chips of uniform shape, size, and color continue on their journey. Alongside the automated quality control systems, trained inspectors conduct manual checks at various points in the production process. These specialists sample chips from every batch, testing for crunchiness, oil content, seasoning distribution, and overall flavor consistency. Taste tests are regularly performed to ensure that every chip has the signature Lay's flavor profile. If an inconsistency is detected, adjustments can be made immediately to the frying temperature, seasoning application, or oil levels to correct the issue before it affects a large quantity of product. While the chips are still warm, they move along the conveyor belt toward the cooling system. The cooling stage is essential because the chips must be brought down to a stable temperature before they can be packaged. If the chips were packed while still warm, condensation could form inside the packaging, leading to sogginess or loss of crispness. To prevent this, the chips pass through cooling tunnels where controlled air circulation gradually reduces their temperature. This step ensures that when the chips reach the packaging stage, they maintain their light, crunchy texture. Once cooled, the chips approach another crucial phase, sorting and weighing. The production line is equipped with highly sensitive scales that measure precise portions of chips. These automated weighing systems are programmed to dispense an exact amount of chips into each bag, ensuring consistency across all packages. The portioning must be extremely precise to meet regulatory weight standards and ensure that customers receive the correct amount of product. Any deviations in weight trigger an automatic adjustment in the dispensing system. After portioning, the chips are directed into the bagging machines, where specially designed Lay's packaging material awaits them. The bags are made from multi-layered, high-barrier film that helps protect the chips from moisture, light, and oxygen, 3 factors that can negatively impact their freshness and taste. The packaging is specifically designed to extend shelf life while preserving the signature crunch and flavor. As the chips drop into the open bags, a stream of nitrogen gas is injected into each bag before sealing. This process, known as nitrogen flushing, serves a crucial purpose. By replacing the oxygen inside the bag with nitrogen, the factory prevents oxidation, which can cause the chips to become stale over time. The nitrogen also helps create a cushioning effect inside the bag, preventing the chips from breaking during transportation and handling. The sealed bags are then heat sealed using precision machinery that ensures an airtight closure. Once sealed, the freshly packed bags of Lay's chips move along the conveyor to the final quality control checkpoint. Here, inspectors verify that the bags are sealed properly, that they contain the correct weight, and that there are no issues with the packaging material. Automated sensors scan the bags for any irregularities, such as improper sealing or printing errors on the labels. If any issues are found, the defective bags are removed from the line before they reach distribution. At this point, the bags are ready for bulk packaging. Large robotic arms carefully arrange the individual chip bags into larger cartons or cases, which are then sealed and labeled for shipment. The cases are stacked onto pallets in an optimized configuration to maximize space efficiency in shipping trucks and storage facilities. The pallets are then loaded onto trucks and transported to Lay's distribution centers, where they are sorted based on their destination. While the chips are being prepared for distribution, data is continuously being collected from the production line to track performance and efficiency. Advanced factory management systems monitor every aspect of the manufacturing process, from the amount of raw materials used to the speed of production. This data allows production teams to identify trends, detect potential inefficiencies, and make real-time adjustments to improve overall operations. Lay's chips are manufactured in multiple facilities worldwide, ensuring that they can reach markets across different regions quickly and efficiently. Each factory follows strict food safety guidelines and adheres to regional regulations to maintain high product standards. The factories are designed to operate at peak efficiency while maintaining rigorous hygiene and cleanliness protocols. Workers in the facility adhere to strict sanitation procedures, including wearing protective clothing, gloves, and hairnets to prevent contamination. Even though the chips have left the factory and are on their way to retailers, the process does not stop there. Lay's has extensive logistics networks that ensure a steady supply of chips to stores and vending machines worldwide. Once the shipments arrive at retail locations, store employees follow best practices for stocking the product, making sure that older batches are sold first while newer shipments are placed behind them to maintain freshness. Lay's packaging is also designed for high visibility on store shelves, making it easy for customers to recognize their favorite flavors at a glance. The branding and design of the bags play a crucial role in marketing, with vibrant colors and flavor indicators clearly displayed. The bags are designed not only to protect the chips, but also to appeal to consumers through enticing imagery and messaging that highlights the quality and taste of the product. The popularity of Lay's chips has led to ongoing innovation in flavors, textures, and packaging options. Consumer feedback plays a major role in shaping new product developments, with research and development teams continuously testing new seasonings and chip varieties. Limited edition flavors and region-specific varieties allow Lay's to cater to different preferences across global markets. This constant evolution keeps the brand fresh and exciting for snack lovers worldwide. With the perfectly seasoned and packaged Lay's chips now prepared for distribution, the process continues beyond the factory walls. While the manufacturing process itself is a highly controlled and precise operation, what happens after the chips leave the factory is just as critical to ensuring that consumers receive a fresh, high-quality product. The logistics and supply chain management of Lay's chips play a crucial role in maintaining their availability across grocery stores, vending machines, and online retailers worldwide. Once the sealed bags are loaded into cartons, they are arranged onto pallets with extreme precision to maximize storage space and minimize movement during transportation. Each carton is labeled with important tracking information, including batch numbers, production dates, and expiration dates, allowing for full traceability. This ensures that if any quality issues arise, specific batches can be quickly identified and recalled if necessary. The pallets are then wrapped securely to prevent shifting during shipment, ensuring that the chips inside remain intact. From the factory, these pallets are transported to Lay's regional distribution centers, where they are sorted based on their intended destination. These distribution hubs act as the central points from which shipments are sent out to retail locations. Temperature and humidity levels inside the warehouses are carefully maintained to ensure that the chips do not absorb excess moisture, which could compromise their crisp texture. At this stage, automated inventory management systems help keep track of shipments, ensuring that stores receive the correct quantities and flavors based on regional demand. As the chips are shipped out to grocery stores, convenience stores, gas stations, and other retail locations, the logistics team continuously monitors their movement. The goal is to minimize the time it takes for a freshly produced bag of chips to reach the shelves, preserving the crunch and flavor that customers expect. Lay's supply chain is designed for efficiency, with trucks following optimized routes to deliver products as quickly as possible. In some cases, chips that are produced in the morning can be on store shelves by the afternoon in nearby regions. At retail locations, store employees are trained to handle Lay's chips carefully during stocking. The lightweight nature of the packaging means that the bags can be susceptible to compression if not stacked correctly. Retailers follow strict guidelines to ensure that chips are displayed properly, with newer shipments placed behind older stock to maintain freshness. In vending machines, the placement of Lay's chips is also optimized to prevent excessive movement that could lead to breakage. The careful handling of the product at every stage is what ensures that customers receive whole, unbroken chips when they open a bag. The journey of Lay's chips does not stop at store shelves. Consumer feedback plays a vital role in shaping future production decisions. Lay's has dedicated teams that analyze purchasing trends, customer reviews, and market demands to determine which flavors and varieties are most popular. This data influences everything from production volume to regional flavor innovations, ensuring that Lay's continues to evolve with consumer preferences. In some cases, limited edition flavors are introduced based on feedback, with certain varieties becoming permanent offerings if they prove successful. As technology advances, Lay's continues to refine its production methods to improve efficiency, reduce waste, and enhance sustainability. One of the major challenges in large-scale snack production is minimizing the environmental impact of operations. To address this, Lay's has implemented initiatives to optimize energy usage in factories, improve water conservation during potato processing, and explore more sustainable packaging solutions. One of the key sustainability efforts involves reducing food waste during production. While some defective chips are removed during quality control, they are not simply discarded. Instead, these chips are often repurposed as animal feed or converted into biofuel, ensuring that as little as possible goes to waste. Additionally, potato scraps from the peeling and slicing process are collected and used for other food products or composting. The use of sustainable farming practices is also a priority for Lay's suppliers. Many of the farms that provide potatoes for Lay's have adopted eco-friendly techniques such as crop rotation, reduced pesticide usage, and precision irrigation to minimize water consumption. By working closely with farmers, Lay's ensures that its supply chain remains both environmentally responsible and efficient. Packaging innovation is another area of focus for Lay's as it looks for ways to make its chip bags more eco-friendly. Traditional chip packaging is made from multi-layered plastic film, which is designed to protect the chips from moisture and air exposure. However, the complex nature of this material makes it difficult to recycle. Lay's has been researching alternative packaging solutions that maintain freshness while reducing plastic waste. Some markets have already seen the introduction of biodegradable or recyclable chip bags, with further developments expected in the future. Automation and artificial intelligence are also playing an increasing role in Lay's production process. Advanced AI-driven quality control systems are being used to detect imperfections with greater accuracy than ever before. These systems can analyze thousands of chips per second, ensuring that every batch meets the highest standards. Additionally, robotic automation is improving efficiency in packaging and palletizing, allowing for faster and more precise handling of products. Beyond production, Lay's continues to engage with consumers through marketing, advertising, and promotions. The brand regularly collaborates with chefs, influencers, and food scientists to introduce new flavors and snack innovations. Limited edition seasonal flavors, cross-cultural fusion varieties, and unique textures like extra crispy or extra flavored chips keep the product line dynamic and exciting for customers. One of the most intriguing aspects of Lay's chips is how different regions have their own exclusive flavors, reflecting the local tastes and culinary preferences of different cultures. In Asia, flavors such as seaweed and spicy hot pot are popular, while in North America, barbecue and sour cream and onion remain among the best sellers. Europe has its own set of unique offerings, including flavors inspired by traditional cheeses and herbs. The ability to adapt to different markets while maintaining the core essence of Lay's chips is what has helped the brand maintain its global appeal. At its core, the production of Lay's chips is a blend of science, technology, and tradition. The balance between maintaining the classic quality that customers expect while continuously innovating is what keeps Lay's at the forefront of the snack industry. From the careful selection of potatoes to the high-speed frying process, precise seasoning application, and advanced packaging techniques, every step is optimized to ensure consistency, flavor, and crunch in every bite. The cycle of chip production never truly stops. Even as one batch is being transported to stores, another is already being prepared in the factory. The efficiency of the Lay's production process ensures that there is always a fresh supply of chips available for consumers. The combination of high-tech manufacturing, sustainability initiatives, and a deep understanding of consumer preferences keeps Lay's chips at the top of the snack food market, continuously evolving to meet the changing tastes and expectations of snack lovers around the world. The process begins with the sourcing of raw ingredients, including hazelnuts, sugar, cocoa powder, palm oil, skim milk powder, and vanillin. These ingredients are delivered to Nutella factories in massive quantities, requiring large-scale handling infrastructure. Hazelnuts, one of the key components of Nutella, are often sourced from Turkey and Italy, two of the largest hazelnut producers in the world. Upon arrival at the factory, hazelnuts are stored in enormous silos or temperature-controlled storage rooms to maintain their freshness. The silos are made of food-grade stainless steel and designed to protect the nuts from humidity and contamination, while allowing for precise dispensing into the production line. The first step in processing the hazelnuts is cleaning. Hazelnuts arrive in bulk shipments, often mixed with debris such as shells, stems, and dirt. To address this, the factory uses a series of cleaning systems that include vibrating screens, air classifiers, and magnetic separators. The vibrating screens shake the nuts to separate them from larger debris, while the air classifiers blow away lightweight impurities like husks and dust. Magnetic separators are also used to detect and remove any metallic particles that might have entered the shipment during harvesting or transport. Once cleaned, the hazelnuts undergo visual inspection using high-speed optical sorting machines equipped with cameras and sensors. These machines identify and remove any defective hazelnuts, such as those with discoloration, cracks, or signs of mold. After cleaning, the hazelnuts move to the roasting stage. Roasting is a crucial step in developing the rich, nutty flavor that characterizes Nutella. In the factory, this is achieved using massive industrial roasting ovens. These ovens are designed with rotating drums or conveyor belts to ensure even roasting. The temperature is carefully controlled, typically ranging between 280 and 320 degrees Fahrenheit, depending on the size and moisture content of the hazelnuts. Sensors monitor the temperature and time to ensure consistency, as over-roasting can lead to bitterness, while under-roasting can result in a lack of flavor. The entire roasting process is automated, and the equipment is designed for continuous operation to handle the high volume of hazelnuts required for production. Once roasted, the hazelnuts are transferred to grinding machines. These machines are equipped with heavy-duty stainless steel blades and rollers that crush the nuts into a fine paste. The grinding process occurs in multiple stages, with each stage further reducing the particle size of the hazelnut paste. In the initial stage, the nuts are coarsely ground into a chunky paste. In the subsequent stages, the paste is refined into a smooth consistency, with particle sizes measuring less than 30 microns. This ultra-fine grinding is essential for achieving Nutella's creamy texture. The equipment used in this process, such as colloid mills and ball mills, is highly specialized and designed to operate under high pressure and at precise speeds. The resulting hazelnut paste is collected in large stainless steel tanks, where it is stored at a controlled temperature to preserve its flavor and consistency. While the hazelnut paste is being prepared, the other ingredients are processed in parallel. Sugar, which provides sweetness to Nutella, is delivered to the factory in bulk containers or tankers. Upon arrival, the sugar is unloaded into silos, equipped with pneumatic conveying systems. These systems use air pressure to transport the sugar from the silos to the milling area, where it is ground into a fine powder. Industrial sugar mills are used for this purpose, and the grinding process ensures that the sugar particles are small enough to dissolve uniformly in the mixture. The factory also incorporates sieving systems to filter out any impurities or oversized sugar particles before they proceed to the blending stage. Cocoa powder, another key ingredient, undergoes a similar process. The cocoa powder is stored in sealed silos to protect it from moisture and contamination. Before being added to the Nutella mixture, the cocoa powder is sifted through vibrating screens to break up clumps and ensure a fine, even consistency. This step is crucial for achieving the smooth texture of the final product, as any clumps could create inconsistencies during blending. Palm oil, which gives Nutella its creamy consistency and prevents separation, is stored in large, temperature-controlled tanks. These tanks are equipped with heating elements to keep the oil in a liquid state, as palm oil tends to solidify at room temperature. The oil is pumped through insulated pipes to the mixing area, where it is carefully measured and added to the blend. The precise control of temperature and flow rate is essential to ensure that the oil integrates smoothly with the other ingredients. Skim milk powder, which adds a subtle dairy flavor and contributes to the creamy texture of Nutella, is stored in sealed containers or silos to prevent exposure to air and moisture. Before being used, the milk powder is sifted and screened to remove any lumps. Factories use advanced pneumatic conveying systems to transport the milk powder from the storage silos to the mixing area, ensuring that the ingredient is handled efficiently and hygienically. The blending process is the heart of Nutella's production, where all the prepared ingredients come together to form the final product. The blending tanks used in Nutella factories are massive, often with capacities of several thousand gallons. These tanks are equipped with high-speed agitators and temperature control systems. The hazelnut paste, sugar powder, cocoa powder, skim milk powder, palm oil, and vanillin are added to the tank in precise proportions, which are controlled by computerized dosing systems. These systems are programmed to weigh and dispense each ingredient accurately, ensuring consistency across batches. During blending, the mixture is heated slightly to help the ingredients combine more effectively. The temperature is carefully monitored, as excessive heat could alter the flavor and texture of the product. The blending tanks are designed to ensure even mixing, with agitators that create a vortex to incorporate all the ingredients thoroughly. The result is a homogeneous mixture with a smooth, creamy consistency. Once the blending process is complete, the mixture undergoes a refining stage. Refining is a critical step that ensures the final product is free of any graininess. The refining process takes place in multi-stage roller mills, which are equipped with heavy-duty steel rollers. These rollers apply immense pressure to the mixture, reducing the particle size of any remaining solids to less than 20 microns. This process not only enhances the texture of Nutella, but also improves its spreadability. The roller mills are fitted with precision sensors that monitor the pressure and temperature during refining, ensuring optimal performance. After refining, the mixture is transferred to the conching stage. Conching is a process borrowed from chocolate manufacturing and involves agitating the mixture in large, heated tanks for several hours. This process helps to further smooth the texture and enhance the flavor of the spread by allowing volatile compounds to evaporate and by evenly distributing the fats and solids. The conching tanks are equipped with paddles or rollers that knead the mixture continuously. The temperature and duration of conching are carefully controlled, as overconching could negatively affect the spread's consistency. The finished Nutella is then pumped into holding tanks, where it is kept at a controlled temperature until it is ready for packaging. These tanks are equipped with agitators to prevent separation and maintain the spread's uniformity. Before the Nutella is packaged, it undergoes a final round of quality control. Samples from each batch are tested for flavor, texture, color, and viscosity. The factory uses advanced laboratory equipment such as viscometers, and spectrophotometers to ensure that the product meets the company's stringent standards. Any deviations from the desired specifications are identified and corrected before the product proceeds to the packaging stage. Packaging is the final step in Nutella's production process, and it is carried out with the same level of precision and efficiency as the earlier stages. The spread is pumped from the holding tanks into automated filling machines, which dispense precise amounts of Nutella into jars. The filling machines are equipped with high-speed nozzles that can fill hundreds of jars per minute. Each jar is made from food-grade plastic or glass and arrives at the factory pre-sterilized to ensure hygiene. The jars are sealed with tamper-proof lids, which are applied and tightened using automated capping machines. Once the jars are sealed, they are conveyed to labeling stations, where Nutella's iconic branding is applied. The labels include important information such as the lot number, production date, and expiration date, which are printed using high-speed inkjet or laser printers. After labeling, the jars are inspected by vision systems that check for defects such as misaligned labels or damaged seals. Any defective jars are automatically removed from the production line. The jars are then packed into cardboard cartons using robotic packing systems. These systems are programmed to arrange the jars in specific configurations to maximize space and protect the jars during transportation. The cartons are sealed and stacked onto pallets using robotic palletizers. The pallets are then wrapped in plastic film for stability and loaded onto trucks or shipping containers for distribution. The entire packaging process is designed for high efficiency, with minimal manual intervention and maximum output. Throughout the factory, automation plays a key role in maintaining efficiency and consistency. Programmable logic controllers and supervisory control and data acquisition systems are used to monitor and control every aspect of the production process. These systems provide real-time data on parameters such as temperature, pressure, and flow rates, allowing operators to make adjustments as needed. The factory is also equipped with advanced robotics and machinery that ensure smooth operation, from ingredient handling to final packaging. Hygiene and safety are top priorities in Nutella factories. Production areas are constructed with food-grade stainless steel surfaces and epoxy-coated floors that are easy to clean and sanitize. Air filtration systems maintain a clean environment by preventing airborne contaminants from entering critical zones. Employees follow strict hygiene protocols, including wearing protective clothing and washing their hands regularly. The factory is regularly inspected to ensure compliance with international food safety standards, guaranteeing that every jar of Nutella is safe for consumption. This intricate, highly automated process ensures that Nutella is consistently smooth, flavorful, and delicious, meeting the high expectations of its millions of fans worldwide. Every step, from the handling of raw ingredients to the final packaging, is a testament to the engineering and precision that go into creating this beloved spread. The result is a product that continues to delight consumers, one jar at a time. Peanut butter, a staple spread beloved worldwide for its creamy or crunchy texture, requires a sophisticated and highly organized manufacturing process to meet the demand for consistent quality and flavor. Behind every jar of peanut butter is an intricate factory process that starts with the raw peanuts and ends with precisely packaged jars ready for distribution. Let's take an in-depth look at the factory production process, exploring the machines, systems, and engineering techniques that make it all possible. The process begins with the sourcing of raw peanuts. These peanuts are typically grown in countries like the United States, China, India, and Argentina, which are among the largest producers of peanuts globally. Peanuts are harvested in vast quantities, cleaned and dried at their source before being shipped to peanut butter manufacturing facilities. Factories require a consistent supply of high-quality peanuts, and to ensure that the raw peanuts are often tested upon arrival for size, moisture content, and overall quality. This ensures only the best peanuts are used for processing. Upon arrival at the factory, peanuts are stored in massive silos or bins designed specifically for food products. These silos are constructed from food-grade stainless steel or coated steel to prevent contamination and ensure proper hygiene. Inside the silos, the peanuts are protected from moisture, pests, and temperature fluctuations. These storage systems are equipped with conveyor systems that efficiently transfer peanuts from the silos to the initial cleaning and processing stages. The first step in processing peanuts is cleaning. Even though peanuts are partially cleaned at their source, factories implement a rigorous cleaning process to ensure no foreign materials or impurities remain. Vibrating screens are used to remove debris such as dirt, stones, and small sticks. Air classifiers blow air through the peanuts to remove lighter debris such as peanut skins or husks. Magnets are also employed to extract any metallic impurities. Optical sorting machines equipped with cameras and sensors scan each peanut as it moves along a conveyor belt, automatically removing any defective peanuts, including those with discoloration, mold, or deformities. After the cleaning process, the peanuts proceed to the roasting stage. Roasting is a critical step in peanut butter production, as it develops the rich, nutty flavor that defines the final product. Factories use industrial roasting ovens to roast the peanuts at controlled temperatures. These ovens come in two main types: batch roasters and continuous roasters. Batch roasters are used for smaller production lines, while continuous roasters, which use conveyor belts to move peanuts through a heated chamber, are used for larger scale operations. The temperature in these roasters typically ranges from 300 to 350 degrees Fahrenheit. The roasting process is closely monitored with temperature sensors and automated control systems to ensure the peanuts are roasted evenly. If some peanuts are over-roasted, they can turn bitter, while under-roasted peanuts may lack flavor. The level of roasting can also be adjusted depending on whether the final peanut butter will have a mild or more robust taste. Once roasted, the peanuts are cooled to stop the cooking process. Cooling is achieved by passing the roasted peanuts through chambers with powerful fans or cool air blowers. This step is crucial because it prevents the peanuts from continuing to cook, which could lead to inconsistencies in flavor. Some factories also use a water spray system to rapidly cool the peanuts, though this is less common as it can add moisture to the product. The cooling systems are designed to operate continuously to keep pace with the output of the roasting ovens. With the peanuts roasted and cooled, the next step is to remove their skins and separate the kernels. Skin removal is done using blanching machines. These machines have rotating drums or abrasive rollers that rub the peanuts, causing the thin outer skin to flake off. Some systems use steam blanching, where the peanuts are exposed to high-pressure steam to loosen the skins before mechanical removal. After blanching, the peanuts pass through air classifiers that blow away the loose skins, leaving behind clean peanut kernels. Factories also use gravity separators to sort peanuts by size and density, ensuring that only uniform peanuts proceed to the grinding stage. Before grinding, the peanuts are inspected again for quality. This is done using high-speed optical sorters that ensure any remaining defective peanuts are removed. Factories often have automated weighing and proportioning systems at this stage to determine the exact amount of peanuts needed for each batch. This level of precision is crucial for maintaining consistency in the flavor and texture of the peanut butter. The grinding process is the heart of peanut butter production. The roasted peanuts are fed into industrial grinders, where they are crushed into a fine paste. This process happens in multiple stages, beginning with coarse grinding and followed by finer grinding. The equipment used for this includes hammer mills and roller mills, which are specifically designed to reduce the peanuts into small, uniform particles. In many factories, the particle size is reduced to less than 20 microns, which is smaller than the diameter of a human hair. Achieving such a fine consistency is essential for the creamy texture that many consumers expect from peanut butter. For crunchy peanut butter, the process is slightly different. In these cases, a portion of the peanuts is coarsely ground and set aside before the final blending stage. These larger peanut pieces are later mixed into the smooth paste to create the characteristic crunchy texture. To prevent the peanut butter from separating, stabilizers such as hydrogenated vegetable oils or palm oil are added during the grinding process. These oils help bind the natural peanut oils to the solid peanut particles, ensuring a smooth and stable product that doesn't separate in the jar. Salt and sugar are also added at this stage to enhance the flavor of the peanut butter. Factories use precision dosing systems to measure and add these ingredients in exact proportions, ensuring every batch has the same taste. After grinding, the peanut butter is sent through a mixing stage, where it is further blended in large stainless steel tanks equipped with high-speed agitators. This stage ensures that the stabilizers, salt, and sugar are evenly distributed throughout the peanut butter. These tanks are often heated slightly to keep the peanut butter at the right consistency for mixing. The temperature is carefully controlled, as overheating can alter the flavor or texture of the peanut butter. Once the mixing is complete, the peanut butter undergoes quality control checks. Samples from each batch are tested in an on-site laboratory for flavor, texture, and consistency. Advanced instruments, such as viscometers, are used to measure the viscosity of the peanut butter, ensuring it meets the desired standards. Factories also use particle size analyzers to confirm that the peanut butter's texture is smooth and uniform. These quality checks are critical, as even slight variations can impact the final product's appeal to consumers. The final step in the manufacturing process is packaging. The peanut butter is pumped from the mixing tanks to filling machines, where it is dispensed into jars. These filling machines are capable of handling thousands of jars per hour, ensuring high efficiency. The jars, typically made of food-grade plastic or glass, arrive at the factory pre-cleaned and are sterilized again before filling. The filling nozzles are designed to dispense precise amounts of peanut butter into each jar, ensuring uniform weight and volume. Once the jars are filled, they move to the capping machines, where tamper-proof lids are applied and tightened. After capping, the jars are conveyed to labeling machines, which apply the brand's signature labels, along with lot numbers and expiration dates for traceability. Vision systems inspect each jar to ensure that the labels are correctly applied and that there are no defects in the seals or packaging. The jars are then packed into cardboard boxes using robotic packing systems. These robots are programmed to arrange the jars in specific configurations to optimize space and protect the jars during transportation. The boxes are sealed and stacked onto pallets using automated palletizing systems. Finally, the pallets are wrapped in plastic film for stability and loaded onto trucks or shipping containers for distribution. Throughout the entire production process, automation plays a vital role in maintaining efficiency and consistency. Factories are equipped with programmable logic controllers, PLCs, and supervisory control and data acquisition, SCADA systems, that monitor and control every aspect of production. These systems provide real-time data on parameters such as temperature, pressure, and flow rates, allowing operators to make adjustments as needed. Robotic systems handle many tasks, from sorting and cleaning peanuts to packaging the final product, reducing the need for manual labor and ensuring precision. Hygiene and safety are also top priorities in peanut butter factories. The production areas are constructed with food-grade stainless steel surfaces and epoxy-coated floors that are easy to clean and sanitize. Positive air pressure systems prevent airborne contaminants from entering critical zones, while strict hygiene protocols ensure that employees maintain cleanliness throughout the production process. The entire facility is regularly inspected to comply with international food safety standards, ensuring that every jar of peanut butter is safe for consumption. Peanut butter production is a complex and highly technical process that relies on advanced machinery, precise engineering, and rigorous quality control. From the cleaning and roasting of peanuts to the grinding, mixing, and packaging of the final product, every step is designed to create a spread that is smooth, flavorful, and consistent. Factories operate with remarkable efficiency, producing thousands of jars per day to meet the global demand for this versatile and beloved product. Strawberry jam production is a fascinating and highly engineered process that combines precision machinery with time-tested techniques to create a smooth, fruity spread. At the core of this process are high-quality strawberries, sugar, pectin, and citric acid, all carefully handled and processed to achieve the perfect consistency and flavor. Inside a modern jam factory, every step is optimized for efficiency, consistency, and food safety. The process begins with the selection and delivery of fresh or frozen strawberries. Factories typically source strawberries from local farms or large-scale suppliers. Frozen strawberries are often preferred for large-scale production because they are preserved at peak ripeness, ensuring consistent flavor year-round. The strawberries arrive in bulk containers and are stored in cold rooms or freezers to maintain their quality until processing begins. Before entering the production line, the fruit undergoes a thorough cleaning process. This includes washing the strawberries in large tanks filled with filtered water, where gentle agitation removes dirt, debris, and any residual pesticides. Once cleaned, the strawberries pass through optical sorting machines. These machines use cameras and sensors to identify and remove defective or discolored fruit. Advanced systems can even detect minute imperfections, ensuring that only the highest quality strawberries make it into the jam. After sorting, the strawberries are sent to cutting or mashing machines, depending on the desired jam texture. For chunkier jams, strawberries are coarsely chopped, while for smooth spreads, they are mashed or pureed into a uniform consistency. The fruit then enters large stainless steel cooking kettles or continuous cooking systems. In these vessels, the strawberries are combined with sugar, which not only sweetens the jam, but also acts as a natural preservative. The sugar is added using automated dosing systems that measure precise quantities to ensure consistent flavor. Pectin, a natural thickening agent derived from fruit, is added to help the jam set. Citric acid is also incorporated to balance the sweetness and enhance the fruit's natural flavor. The mixture is slowly heated, with temperatures reaching up to 220 degrees Fahrenheit to activate the pectin and achieve the ideal gel-like consistency. During cooking, the jam undergoes constant agitation to prevent scorching and ensure even heating. Steam-jacketed kettles or vacuum cookers are often used, as they allow for rapid and uniform heating. Modern vacuum systems are particularly advantageous because they enable cooking at lower temperatures, preserving the fresh flavor and bright color of the strawberries. Throughout the cooking process, sensors monitor the temperature, pH levels, and viscosity of the jam, ensuring that the final product meets strict quality standards. Once the jam reaches the desired consistency, it is pumped through a series of filters to remove any seeds or large pieces if a smoother texture is desired. The finished jam is then transferred to filling machines. These machines dispense precise amounts of jam into sterilized glass jars or plastic containers. The jars are immediately sealed with tamper-proof lids to maintain freshness and prevent contamination. After sealing, the jars are passed through pasteurization tunnels, where they are briefly heated to destroy any remaining microorganisms. Finally, the jars are labeled, inspected, and packed into cartons using robotic packaging systems. The entire process is highly automated, ensuring efficiency and consistent quality, from the arrival of fresh strawberries to the delivery of jars to store shelves. This seamless blend of traditional cooking techniques and advanced technology ensures that every jar of strawberry jam is rich in flavor, perfectly textured, and safe for consumers to enjoy. For butter production, upon arrival at the factory, the cream undergoes comprehensive testing to verify its fat content microbial levels, and overall purity. This initial assessment ensures that only the highest quality cream enters the production line. Once approved, the cream is stored in large refrigerated tanks, where it is maintained at a precise temperature to preserve its freshness until processing begins. Standardization is the next critical step in butter production. This involves adjusting the fat content of the cream to a consistent level, usually around 40%, which is optimal for churning into butter. Advanced machinery is employed to blend cream with varying fat contents or to add skim milk as needed. This precise adjustment ensures uniformity in the final product. Standardization also allows factories to produce different types of butter, such as light or extra rich varieties, by altering the fat percentage accordingly. The standardized cream is then pasteurized to eliminate any harmful bacteria and to enhance shelf stability. Pasteurization involves heating the cream to a specific temperature for a set duration, followed by rapid cooling to prevent spoilage. After pasteurization, the cream enters the aging phase. This step is crucial for developing the desired texture and flavor profile of the butter. During aging, the cream is stored at a controlled temperature for several hours, allowing natural enzymes and lactic acid bacteria to work on the fat molecules. For cultured butter production, additional bacterial cultures are introduced during this stage to impart a richer, more complex flavor. The aging process can vary depending on the type of butter being produced, with some recipes requiring longer periods to achieve the desired characteristics. Once the cream has been adequately aged, it moves to the churning stage. In industrial settings, large-scale churns are used to efficiently process vast quantities of cream. The churning process separates the butterfat from the buttermilk through continuous agitation. As the cream is churned, the fat globules begin to coalesce, forming small grains of butter. These grains gradually grow larger as the churning continues, eventually forming a cohesive mass of butter. The buttermilk, which is the liquid component remaining after the fat solids have separated, is drained off and often used in other food products, such as baking ingredients or animal feed. Following churning, the butter mass undergoes washing to remove any residual buttermilk and impurities. Cold water is carefully sprayed over the butter while it is continuously agitated to ensure thorough cleaning. This step is vital for improving the texture and extending the shelf life of the butter. After washing, the butter is worked to achieve the desired consistency. If salted butter is being produced, salt is added at this stage to act as a preservative and enhance flavor. The amount of salt varies based on the specific product requirements and regional preferences. The working process involves kneading the butter to distribute the salt evenly and to expel any remaining water. The packaging phase is the next significant step in butter production. At this point, the butter is shaped into blocks, tubs, or sticks, depending on the intended market. Modern factories utilize automated equipment to shape and package the butter efficiently. Each piece is weighed precisely to ensure accurate portioning. Packaging materials are selected for their ability to protect the butter from environmental factors such as light, air, and moisture, which can degrade its quality. Common packaging options include foil-wrapped blocks, plastic tubs, and stick wrappers. The design of the packaging often incorporates branding elements and nutritional information to appeal to consumers. Throughout the entire production process, quality control measures are rigorously enforced to maintain the integrity of the butter. Multiple checks and tests are conducted at various stages to ensure compliance with safety and quality standards. Microbiological testing confirms the absence of harmful bacteria, while physical tests assess the texture and spreadability of the butter. Chemical analysis verifies the fat content and flavor profiles. Sensory evaluation panels may also assess the taste, aroma, and appearance of the butter to ensure it meets consumer expectations. Any batch that fails to meet these criteria is either reprocessed or discarded to uphold product quality. Factories implementing sustainable practices aim to minimize their environmental impact. Waste materials, such as the buttermilk separated during churning, can be further processed to create valuable byproducts like whey protein. Energy usage is optimized through the recovery of waste heat generated during thermal processes, such as pasteurization, which can be reused within the factory. Water used in washing and cleaning operations is treated before discharge to comply with environmental regulations. These efforts contribute to a more sustainable and eco-friendly production process. Technological advancements have significantly enhanced the efficiency and precision of butter production in factories. Computer-controlled systems monitor and adjust parameters such as temperature, speed, and timing during each stage of the process. Robotics and artificial intelligence are increasingly integrated into factory operations to improve accuracy and reduce human error. For example, automated sensors can detect inconsistencies in the cream's fat content during standardization and make real-time adjustments to correct them. These innovations not only streamline the production process, but also allow for greater customization and flexibility in meeting diverse market demands. Consumer trends play a pivotal role in shaping butter production strategies. With growing interest in health-conscious eating, there is an increasing demand for low-fat or plant-based alternatives. Factories respond by developing new recipes and production methods to cater to these emerging preferences. Transparency in sourcing and production practices is becoming increasingly important to consumers, leading factories to adopt traceability systems that provide detailed information about the origin and journey of their products. This builds trust and enhances brand loyalty among customers. The global market for butter is influenced by a variety of factors, including dietary habits, cultural preferences, and economic conditions. Factories must remain adaptable and responsive to these changes to stay competitive. They invest in research and development to innovate and improve their products continuously. Collaboration with suppliers, retailers, and consumers helps factories understand market needs and align their production strategies accordingly. By leveraging technology, adhering to quality standards, and embracing sustainable practices, butter factories aim to deliver superior products that meet and exceed customer expectations. In the context of industrial butter production, the procurement of raw cream is a meticulous process. Cream is sourced from dairy farms that adhere to stringent quality protocols. Upon arrival at the factory, the cream is tested for fat content, microbial levels, and overall purity. Approved cream is stored in refrigerated tanks at a precise temperature to maintain freshness. Standardization adjusts the fat content to approximately 40%, using advanced machinery to blend cream with varying fat contents or add skim milk as necessary. This step ensures uniformity in the final product and enables the production of different butter varieties by altering the fat percentage. Pasteurization follows standardization, involving heating the cream to a specific temperature for a set duration to eliminate harmful bacteria and enhance shelf stability. After pasteurization, the cream enters the aging phase, where it is stored at a controlled temperature for several hours to develop the desired texture and flavor. Cultured butter production introduces additional bacterial cultures during this stage to impart a richer flavor. Churning separates the butterfat from the buttermilk through continuous agitation, forming small grains of butter that grow larger as the process continues. The buttermilk is drained off and often utilized in other food products. Washing removes residual buttermilk and impurities from the butter mass using cold water while it is continuously agitated. Salt is added during the working process if producing salted butter, enhancing flavor and acting as a preservative. Automated equipment shapes and packages the butter into blocks, tubs, or sticks with precise weighing, ensuring accurate portioning. Packaging materials protect the butter from environmental factors, incorporating branding elements and nutritional information to appeal to consumers. Quality control measures are enforced throughout the production process, with multiple checks and tests ensuring compliance with safety and quality standards. Microbiological testing confirms the absence of harmful bacteria, Physical tests assess texture and spreadability, and chemical analysis verifies fat content and flavor profiles. Sensory evaluation panels assess taste, aroma, and appearance to meet consumer expectations. Sustainable practices minimize environmental impact, recycling waste materials, optimizing energy usage, and treating water before discharge. Technological advancements enhance efficiency and precision with computer-controlled systems, monitoring and adjusting parameters during production. Consumer trends shape production strategies, driving innovation in recipes and methods to meet health-conscious demands and build transparency through traceability systems. Collaboration with stakeholders helps factories understand market needs and align production strategies accordingly, delivering superior products that exceed customer expectations. Industrial butter production involves intricate steps and considerations, balancing tradition with innovation. From cream preparation to final packaging, every stage is meticulously controlled to ensure high-quality butter. Advanced technologies, adherence to quality standards, and sustainability initiatives enhance efficiency and reduce environmental impact. Adapting to consumer trends ensures relevance in a competitive market, demonstrating the industry's commitment to responsible and forward-thinking practices. Butter production in factories combines art and science, transforming simple cream into a beloved staple enjoyed worldwide. The journey of butter from cream to table showcases the complexity and sophistication involved in industrial-scale production. Precise control over every stage, rigorous quality assurance, and integration of modern technologies highlight the dedication to delivering a versatile and delicious product. This exploration reveals the detailed processes and considerations that define butter production in a factory setting. Cream acquisition begins with sourcing from dairy farms, adhering to quality protocols. Testing ensures fat content, microbial levels, and purity meet standards. Approved cream is stored in refrigerated tanks at controlled temperatures. Standardization adjusts fat content to 40% using advanced machinery, enabling uniformity and variety production. Pasteurization eliminates bacteria and enhances shelf stability through precise heating and cooling. Aging develops texture and flavor, with cultured butter benefiting from additional bacterial cultures. Churning separates butterfat from buttermilk, forming grains that grow larger during continuous agitation. Buttermilk is drained off for reuse in other food products. Washing removes impurities using cold water while agitating the butter mass. Salt is added during the working process for flavor enhancement and preservation. Automated equipment shapes and packages butter into blocks, tubs, or sticks, with precise weighing ensuring accurate portions. Packaging materials protect against environmental factors, incorporating branding and nutritional information. Quality control enforces safety and quality standards through microbiological testing, physical assessments, and chemical analyses. Sensory evaluations ensure taste, aroma, and appearance meet expectations. Sustainable practices minimize environmental impact by recycling waste, optimizing energy use, and treating water before discharge. Technological advancements enhance efficiency and precision, with computer-controlled systems monitoring production parameters. Consumer trends drive innovation in recipes and methods, promoting health-conscious alternatives and transparency through traceability systems. Collaboration with stakeholders aligns production strategies with market needs, delivering superior products exceeding customer expectations. The creation of mayonnaise in a factory is an intricate process that combines the precision of science with the artistry of culinary expertise. At its essence, mayonnaise is an emulsion, a delicate blend of oil, water, and egg yolks, stabilized by natural emulsifiers such as lecithin. This journey from raw ingredients to jarred condiment involves numerous steps, each meticulously controlled to ensure consistency, flavor, and safety. It all begins with the procurement of high-quality raw materials. Eggs, vegetable oil, vinegar, and various seasonings form the foundation of mayonnaise production. Eggs, particularly their yolks, are crucial because they contain lecithin, a natural emulsifier that binds oil and water together. These eggs must meet stringent standards for freshness and cleanliness before entering the facility. Similarly, the choice of oil is critical. It must be pure and flavorful, as it significantly influences the taste of the final product. Vinegar serves dual purposes, acting as both a preservative and a flavor enhancer. Additional seasonings like salt, sugar, mustard powder, or garlic extract may also be added depending on the desired variety. Once these ingredients arrive at the factory, they undergo rigorous testing to ensure compliance with quality specifications. Microbial contamination, pH levels, and chemical composition are carefully checked. Approved ingredients are then stored in large tanks or silos under controlled conditions to preserve their integrity until needed. Eggs are often pasteurized at this stage to eliminate any potential pathogens, ensuring the safety of the final product. The heart of mayonnaise production lies in the mixing process, where individual components are transformed into a smooth, creamy emulsion. Initially, egg yolks are blended with vinegar and seasonings in a specialized mixer. This mixture acts as the base, providing the foundation for the emulsion. As the blending continues, liquid vegetable oil is slowly introduced into the mix. The key here is gradual addition. Pouring the oil too quickly can destabilize the emulsion, leading to separation. Advanced machinery, equipped with precise flow control mechanisms, ensures that the oil is incorporated at just the right rate, maintaining stability throughout the process. During this phase, the mechanical action of the mixer helps break down the oil into microscopic droplets, dispersing them evenly within the aqueous phase. Lecithin present in the egg yolks plays a pivotal role here, acting as a bridge between the oil and water molecules to prevent them from separating. This step requires careful monitoring of temperature and speed to achieve optimal results. Too much heat can denature the proteins in the egg yolks, compromising the emulsion, while insufficient agitation might leave the mixture lumpy or inconsistent. Once the initial emulsion has been formed, further adjustments may be made to fine-tune the texture and flavor. Additional ingredients, such as stabilizers or thickeners, may be added to enhance the viscosity of the mayonnaise, ensuring it maintains its creamy consistency over time. Some manufacturers also incorporate antioxidants to extend shelf life and preserve freshness. These additions are done using automated systems that measure quantities with remarkable accuracy, guaranteeing uniformity across batches. After the mixing process is complete, the mayonnaise moves to the homogenization stage. Homogenization involves subjecting the mixture to intense pressure through narrow channels, breaking down any remaining large oil droplets into even smaller particles. This step not only improves the stability of the emulsion, but also enhances the smoothness and silkiness of the final product. Modern factories use sophisticated homogenizers capable of processing vast quantities of mayonnaise efficiently while maintaining consistent quality. Next comes the pasteurization phase, a critical step in ensuring the safety of the mayonnaise. Although the eggs have already been pasteurized earlier in the process, the entire mixture is heated to a specific temperature for a set period to eliminate any residual bacteria or microorganisms. Pasteurization also helps stabilize the flavors, allowing them to meld together harmoniously. After heating, the mayonnaise is rapidly cooled to prevent degradation of its texture or nutritional value. With the mayonnaise now fully prepared, it proceeds to the packaging stage. Here, advanced filling machines dispense precise amounts of the product into jars, bottles, or sachets, depending on the intended market. Packaging materials are chosen for their ability to protect the mayonnaise from light, air, and moisture, which could otherwise compromise its quality. For instance, opaque plastic containers or glass jars with tight-fitting lids are commonly used to shield the contents from external factors. Each package is sealed hermetically to ensure freshness until it reaches the consumer. Quality assurance is woven seamlessly into every aspect of mayonnaise production. Throughout the process, samples are regularly taken and analyzed to verify that the product meets all required standards. Microbiological tests confirm the absence of harmful bacteria, while sensory evaluations assess factors such as color, aroma, and taste. Physical properties such as viscosity and spreadability are also measured to ensure the mayonnaise performs well when used in culinary applications. Any deviations from established norms trigger immediate corrective actions, ensuring that only the highest quality mayonnaise leaves the factory. In addition to producing standard mayonnaise, many factories specialize in creating variations tailored to specific tastes and dietary preferences. Reduced fat versions substitute some of the oil with water or other ingredients to lower calorie content without sacrificing flavor. Low sodium options cater to health-conscious consumers, while organic or vegan alternatives appeal to those seeking more sustainable or plant-based choices. These specialty products require unique formulations and production techniques, showcasing the adaptability of modern manufacturing facilities. Sustainability plays a significant role in contemporary mayonnaise production. Factories increasingly focus on minimizing waste, conserving energy, and reducing environmental impact. Waste oils generated during production are recycled into biofuels or other useful byproducts, while water used in cleaning processes is treated before discharge to comply with ecological regulations. Energy-efficient equipment and renewable energy sources further contribute to greener operations. Moreover, sourcing ingredients responsibly, such as using cage-free eggs or sustainably harvested oils, aligns with growing consumer demand for ethically produced goods. Technological advancements continue to revolutionize the mayonnaise industry. Automation streamlines production lines, enabling faster throughput while maintaining exceptional quality. Artificial intelligence and machine learning algorithms optimize processes by predicting equipment maintenance needs, identifying inefficiencies, and suggesting improvements. Robotics handle repetitive tasks with unmatched precision, freeing human workers to focus on higher value activities. These innovations not only boost productivity, but also allow factories to respond swiftly to changing market demands. Consumer trends heavily influence the evolution of mayonnaise production. With increasing awareness about nutrition and wellness, there is a growing interest in healthier alternatives and transparent labeling. Manufacturers address these concerns by developing innovative recipes and providing detailed information about ingredient origins and production methods. Customization capabilities enable factories to produce niche products catering to regional preferences or emerging dietary fads, such as keto-friendly or gluten-free mayonnaises. Global trade dynamics also shape the way mayonnaise is manufactured. Export markets demand adherence to diverse regulatory frameworks, requiring factories to implement flexible systems capable of meeting varying international standards. Collaboration with suppliers, distributors, and retailers ensures alignment with global supply chains, facilitating timely delivery of products worldwide. Continuous investment in research and development keeps factories at the forefront of technological innovation, ensuring their competitiveness in an ever-evolving marketplace. Beyond the technical aspects of production, the cultural significance of mayonnaise cannot be overlooked. In many regions, it is more than just a condiment. It is a symbol of culinary tradition and innovation. From classic sandwiches to elaborate dressings, mayonnaise serves as a versatile ingredient that enhances countless dishes. Its widespread popularity has driven manufacturers to explore new flavors and textures, expanding its appeal beyond traditional boundaries. For example, flavored varieties infused with herbs, spices, or even fruit extracts offer exciting options for adventurous cooks and diners alike. Factories also prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control points. Systems identify potential hazards and establish measures to prevent them. Regular audits and certifications ensure compliance with local and international regulations. Employee training programs emphasize hygiene practices and proper handling procedures, reinforcing a culture of safety throughout the organization. Packaging design plays a vital role in the marketing and distribution of mayonnaise. Modern factories invest heavily in developing attractive and functional packaging solutions that appeal to consumers while protecting the product. Innovations in material science have led to the creation of lightweight yet durable containers that reduce shipping costs and environmental impact. Resealable caps and squeezable bottles enhance user convenience, making it easier for customers to enjoy the product without compromising freshness. Supply chain management is another critical component of successful mayonnaise production. Efficient logistics ensure a steady flow of raw materials into the factory and finished goods out to retailers. Strategic partnerships with suppliers help secure reliable sources of high-quality ingredients, while relationships with distributors facilitate rapid delivery to diverse markets. Real-time data analytics enable factories to forecast demand accurately, optimizing inventory levels and reducing waste. Research and development remain central to the growth, and engineers continuously experiment with new formulations, processing techniques, and packaging technologies to improve product quality and sustainability. Emerging trends in biotechnology and fermentation offer promising avenues for enhancing flavor profiles and extending shelf life. Collaborations with academic institutions and research organizations provide valuable insights into cutting-edge developments that can be applied to commercial production. The economic impact of mayonnaise production extends far beyond the factory floor. It supports jobs in agriculture, transportation, retail, and related industries, contributing significantly to local and national economies. By investing in community initiatives and sustainable practices, manufacturers demonstrate their commitment to corporate responsibility and long-term viability. Programs aimed at reducing carbon footprints, conserving water, and promoting biodiversity align with broader societal goals of environmental stewardship. As consumer preferences evolve, so too does the nature of mayonnaise production. Health-conscious individuals seek products with fewer additives and artificial ingredients, driving manufacturers to adopt cleaner label approaches. Clear communication about ingredient sourcing and production methods builds trust and fosters loyalty among discerning customers. Educational campaigns highlighting the benefits of mayonnaise as part of a balanced diet further reinforce its position as a staple in kitchens worldwide. Finally, the future of mayonnaise production promises exciting possibilities. Advances in automation, digitalization, and artificial intelligence will likely transform traditional manufacturing processes, enabling greater efficiency and flexibility. Personalized nutrition platforms may one day allow consumers to customize their own mayonnaise blends based on individual dietary needs and preferences. Meanwhile, ongoing efforts to reduce environmental impact and promote social responsibility will ensure that mayonnaise remains a beloved and sustainable choice for generations to come. Through precise control of every stage, from ingredient preparation to final packaging, factories ensure that each jar of mayonnaise delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind the seemingly straightforward process of making mayonnaise, highlighting the dedication and expertise required to bring this indispensable condiment to tables everywhere. The production of olive oil in a factory is a meticulous process that combines ancient traditions with modern technology to create one of the world's most revered culinary staples. Olive oil, often referred to as liquid gold, has been cherished for millennia for its rich flavor, health benefits, and versatility in cooking. The journey from olive groves to bottling lines involves several intricate steps, each designed to preserve the natural qualities of the olives while ensuring consistency and quality. It all begins with the cultivation of olives, which are grown primarily in regions with Mediterranean climates such as Spain, Italy, Greece, and parts of North Africa. The choice of olive variety plays a significant role in determining the flavor profile of the final product. Different varieties produce oils with distinct characteristics. Some are fruity and mild, while others are robust and peppery. Harvesting typically occurs between late autumn and early winter when the olives reach their peak ripeness. Timing is crucial because underripe olives yield less oil, while overripe ones can lead to off flavors. Once harvested, the olives are transported to the factory where they undergo rigorous quality checks. These inspections ensure that only healthy, undamaged fruits are used in production. Any leaves, stems, or debris are removed during this stage to prevent contamination. The cleaned olives are then stored temporarily in ventilated containers to maintain freshness until processing begins. The first step in the factory is washing the olives. This process removes dirt, dust, and any remaining impurities from the surface of the fruit. Clean water is sprayed over the olives while they are gently agitated to ensure thorough rinsing. After washing, the olives proceed to the milling stage, where they are crushed into a paste. Traditionally, stone mills were used for this purpose, but modern factories employ stainless steel crushers or hammer mills for greater efficiency. The goal is to break down the cell walls of the olives, releasing the oil trapped inside. Following milling, the olive paste moves to the malaxation phase. Malaxation involves slowly stirring the paste at a controlled temperature to allow small droplets of oil to coalesce into larger ones. This step is critical because it enhances the extraction rate and improves the quality of the oil by promoting better separation of solids and liquids. The duration of malaxation varies depending on factors such as olive variety and desired flavor profile, but it typically lasts between 20 and 40 minutes. After malaxation, the next step is decantation, where the olive paste is separated into its three main components: oil, water, and solid residue known as pomace. In traditional methods, this was achieved using centrifuges or pressing systems. Modern factories predominantly use horizontal decanter centrifuges, which spin the paste at high speeds to separate the heavier solid particles from the lighter liquid phases. The resulting mixture of oil and water is further refined in a second stage centrifuge, which separates the oil completely from any remaining water or fine particles. At this point, the crude olive oil undergoes additional treatments to refine its quality. Filtration is often employed to remove any residual suspended solids, producing a clearer and more stable product. Some manufacturers also implement cold filtration techniques to preserve the natural flavors and aromas of the oil. For extra virgin olive oil, minimal processing is preferred to retain its superior taste and nutritional value. However, lower grade oils may be subjected to chemical refining processes to improve clarity, color, and shelf life. Storage is another critical aspect of olive oil production. Once extracted, the oil is transferred to large stainless steel tanks where it is kept at controlled temperatures to prevent oxidation and degradation. These tanks are equipped with inert gas systems to displace oxygen, further protecting the oil's quality. During storage, the oil continues to settle, allowing any remaining microscopic particles to sink to the bottom of the tank. Periodic sampling and analysis ensure that the oil maintains its desired characteristics throughout this period. Packaging represents the final stage of the production process. Olive oil is bottled in various sizes and formats, ranging from small glass bottles to bulk plastic containers, depending on the target market. Packaging materials are chosen for their ability to shield the oil from light, air, and moisture, which can negatively affect its quality. Dark-colored glass or opaque plastic bottles are commonly used to protect against UV exposure, while tight-fitting caps ensure an airtight seal. Labels provide important information about the oil's origin, grade, and nutritional content, helping consumers make informed purchasing decisions. Quality control is woven into every aspect of olive oil production. Throughout the process, samples are regularly taken and analyzed to verify compliance with strict international standards. Sensory evaluations assess factors such as aroma, taste, and mouthfeel, ensuring the oil meets expectations for its designated grade. Chemical analyses measure parameters like acidity levels, peroxide values, and fatty acid composition to confirm purity and authenticity. Any deviations from established norms trigger immediate corrective actions, guaranteeing that only the highest quality olive oil reaches the market. In addition to producing standard olive oil, many factories specialize in creating premium varieties tailored to specific tastes and dietary preferences. Extra virgin olive oil, considered the finest grade, is produced using mechanical means only, without heat or chemicals, to preserve its natural flavors and antioxidants. Virgin olive oil undergoes slightly more processing, but still retains much of its original character. Refined olive oil, on the other hand, is treated with chemical agents to neutralize defects and achieve uniformity in taste and appearance. Specialty oils infused with herbs, spices, or citrus extracts offer unique flavor profiles that appeal to adventurous cooks and diners alike. Sustainability is increasingly becoming a priority in olive oil production. Factories adopt eco-friendly practices to minimize waste, conserve resources, and reduce environmental impact. Pomace, the solid residue left after extraction, is often recycled into biofuels or animal feed, reducing landfill contributions. Water used in cleaning processes is treated before discharge to comply with ecological regulations. Energy-efficient equipment and renewable energy sources further contribute to greener operations. Moreover, sourcing olives responsibly, such as supporting local farmers who practice sustainable agriculture, aligns with growing consumer demand for ethically produced goods. Technological advancements continue to revolutionize the olive oil industry. Automation streamlines production lines, enabling faster throughput while maintaining exceptional quality. Artificial intelligence and machine learning algorithms optimize processes by predicting equipment maintenance needs, identifying inefficiencies, and suggesting improvements. Robotics handle repetitive tasks with unmatched precision, freeing human workers to focus on higher value activities. These innovations not only boost productivity, but also allow factories to respond swiftly to changing market demands. Consumer trends heavily influence the evolution of olive oil production. With increasing awareness about nutrition and wellness, there is a growing interest in healthier alternatives and transparent labeling. Manufacturers address these concerns by developing innovative formulations and providing detailed information about ingredient origins and production methods. Customization capabilities enable factories to produce niche products catering to regional preferences or emerging dietary fads, such as organic or keto-friendly options. Global trade dynamics also shape the way olive oil is manufactured. Export markets demand adherence to diverse regulatory frameworks, requiring factories to implement flexible systems capable of meeting varying international standards. Collaboration with suppliers, distributors, and retailers ensures alignment with global supply chains, facilitating timely delivery of products worldwide. Continuous investment in research and development keeps factories at the forefront of technological innovation, ensuring their competitiveness in an ever-evolving marketplace. Beyond the technical aspects of production, the cultural significance of olive oil cannot be overlooked. In many regions, it is more than just a cooking ingredient. It is a symbol of heritage and tradition. From drizzling it over fresh bread to using it as the base for elaborate sauces, olive oil serves as a versatile foundation for countless dishes. Its widespread popularity has driven manufacturers to explore new applications and presentations, expanding its appeal beyond traditional boundaries. Factories also prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control. Point systems identify potential hazards and establish measures to prevent them. Regular audits and certifications ensure compliance with local and international regulations. Employee training programs emphasize hygiene practices and proper handling procedures, reinforcing a culture of safety throughout the organization. Packaging design plays a vital role in the marketing and distribution of olive oil. Modern factories invest heavily in developing attractive and functional packaging solutions that appeal to consumers while protecting the product. Innovations in material science have led to the creation of lightweight yet durable containers that reduce shipping costs and environmental impact. Resealable caps and pour spouts enhance user convenience, making it easier for customers to enjoy the product without compromising freshness. Supply chain management is another critical component of successful olive oil production. Efficient logistics ensure a steady flow of raw materials into the factory and finished goods out to retailers. Strategic partnerships with suppliers help secure reliable sources of high-quality olives, while relationships with distributors facilitate rapid delivery to diverse markets. Real-time data analytics enable factories to forecast demand accurately, optimizing inventory levels and reducing waste. Research and development remain central to the growth of the olive oil industry. Scientists and engineers continuously experiment with new formulations, processing techniques, and packaging technologies to improve product quality and sustainability. Emerging trends in biotechnology and fermentation offer promising avenues for enhancing flavor profiles and extending shelf life. Collaborations with academic institutions and research organizations provide valuable insights into cutting-edge developments that can be applied to commercial production. The economic impact of olive oil production extends far beyond the factory floor. It supports jobs in agriculture, transportation, retail, and related industries, contributing significantly to local and national economies. By investing in community initiatives and sustainable practices, manufacturers demonstrate their commitment to corporate responsibility and long-term viability. Programs aimed at reducing carbon footprints, conserving water, and promoting biodiversity align with broader societal goals of environmental stewardship. As consumer preferences evolve, so too does the nature of olive oil production. Health-conscious individuals seek products with fewer additives and artificial ingredients, driving manufacturers to adopt cleaner label approaches. Clear communication about ingredient sourcing and production methods builds trust and fosters loyalty among discerning customers. Educational campaigns highlighting the benefits of olive oil as part of a balanced diet further reinforce its position as a staple in kitchens worldwide. Finally, the future of olive oil production promises exciting possibilities. Advances in automation, digitalization, and artificial intelligence will likely transform traditional manufacturing processes, enabling greater efficiency and flexibility. Personalized nutrition platforms may one day allow consumers to customize their own olive oil blends based on individual dietary needs and preferences. Meanwhile, ongoing efforts to reduce environmental impact and promote social responsibility will ensure that olive oil remains a beloved and sustainable choice for generations to come. Through precise control of every stage, from olive cultivation to final packaging, factories ensure that each bottle of olive oil delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind the seemingly straightforward process of making olive oil, highlighting the dedication and expertise required to bring this indispensable liquid to tables everywhere. The production of whipped cream in a factory is a highly refined process that combines traditional techniques with modern technology to create one of the most beloved and versatile dairy products. Whipped cream, known for its light, airy texture and rich flavor, has become an essential ingredient in desserts, beverages, and culinary creations worldwide. The journey from raw materials to finished product involves several intricate steps, each meticulously controlled to ensure consistency, quality, and safety. It all begins with the procurement of high-quality cream, which serves as the foundation of whipped cream production. Cream is typically sourced from fresh milk, separated through centrifugation or other mechanical processes to concentrate the fat content. For whipped cream cream with a fat content of around 35% is ideal, as it provides the necessary structure and stability when aerated. The cream must meet stringent quality standards, including checks for purity, fat content, and microbial levels before entering the factory. Once approved, the cream is stored in refrigerated tanks at a precise temperature to preserve its freshness until processing begins. Upon arrival at the factory, the cream undergoes rigorous testing to ensure it meets the required specifications. This includes microbiological testing to confirm the absence of harmful bacteria, chemical analysis to verify fat content, and sensory evaluations to assess flavor and aroma. Approved cream is then standardized to ensure uniformity across batches. Standardization involves adjusting the fat content to the desired level using advanced machinery that blends cream with varying fat contents or adds skim milk as needed. This step is critical for maintaining consistent product quality and enabling customization for different varieties of whipped cream. After standardization, the cream moves to the pasteurization stage. Pasteurization is a crucial step in ensuring the safety and shelf life of the whipped cream. During this process, the cream is heated to a specific temperature for a set duration, followed by rapid cooling. This eliminates any harmful microorganisms while preserving the cream's natural flavors and nutritional properties. Pasteurized cream is then stored at a controlled temperature to maintain its quality until further processing. The next phase in whipped cream production is stabilization. To enhance the cream's ability to hold air and maintain its fluffy texture, stabilizers such as guar gum, carrageenan, or xanthan gum may be added. These ingredients help prevent separation and improve the cream's whipping properties. Emulsifiers like mono and diglycerides may also be incorporated to ensure smooth blending and even distribution of fat globules during aeration. The choice of stabilizers and emulsifiers depends on the desired characteristics of the final product and regulatory requirements in different markets. Once stabilized, the cream proceeds to the whipping stage, where it is transformed into its characteristic light and airy form. In industrial settings, this is achieved using large-scale whipping machines capable of processing vast quantities of cream efficiently. The whipping process involves introducing air into the cream while agitating it at a controlled speed and temperature. As the cream is whipped, the fat globules coalesce, forming a network that traps air bubbles, creating the signature texture of whipped cream. The degree of aeration is carefully monitored to achieve the desired density and volume. During whipping, additional ingredients such as sugar, vanilla extract, or other flavorings may be incorporated to enhance the taste and appeal of the whipped cream. Sugar not only sweetens the product, but also helps stabilize the foam by increasing viscosity and improving bubble formation. Flavorings are carefully selected and measured to ensure they complement the natural richness of the cream without overpowering it. Some manufacturers produce flavored variations, such as chocolate, coffee, or fruit-infused whipped creams, catering to diverse consumer preferences. After whipping, the cream is cooled to stabilize its structure and prevent degradation. Cooling is typically done in a controlled environment to ensure the whipped cream retains its shape and texture. At this stage, the product may undergo further adjustments to fine-tune its consistency and appearance. Advanced machinery is used to measure parameters such as overrun and firmness, ensuring the whipped cream meets the desired specifications. Packaging represents the final stage of whipped cream production. Modern factories utilize automated equipment to dispense precise amounts of the product into various formats, including aerosol cans, plastic tubs, or flexible pouches. Aerosol packaging is particularly popular due to its convenience and ease of use, allowing consumers to spray the whipped cream directly onto their favorite foods. Nitrous oxide is often used as the propellant in aerosol cans, providing both the means of dispensing and contributing to the cream's light texture. Packaging materials are chosen for their ability to protect the whipped cream from light, air, and moisture, which can affect its quality. Labels provide important information about the product's ingredients, nutritional content, and usage instructions, helping consumers make informed choices. Quality control is an integral part of whipped cream production, implemented throughout every stage of the process. Samples are regularly taken and analyzed to verify compliance with strict international standards. Microbiological tests confirm the absence of harmful bacteria, while physical and chemical analyses assess factors such as overrun, firmness, and fat content. Sensory evaluations evaluate the whipped cream's flavor, aroma, and texture to ensure it meets consumer expectations. Any deviations from established norms trigger immediate corrective actions, guaranteeing that only the highest quality whipped cream reaches the market. In addition to producing standard whipped cream, many factories specialize in creating premium varieties tailored to specific tastes and dietary preferences. Low-fat or non-dairy alternatives cater to health-conscious consumers, while organic options appeal to those seeking more sustainable choices. Specialty flavors and textures offer exciting options for adventurous cooks and diners alike. These variations require unique formulations and production techniques, showcasing the adaptability of modern manufacturing facilities. Sustainability plays a significant role in contemporary whipped cream production. Factories increasingly focus on minimizing waste, conserving resources, and reducing environmental impact. Waste cream generated during production is recycled into animal feed or biofuels, while water used in cleaning processes is treated before discharge to comply with ecological regulations. Energy-efficient equipment and renewable energy sources further contribute to greener operations. Moreover, sourcing cream responsibly, such as supporting local farmers who practice sustainable agriculture, aligns with growing consumer demand for ethically produced goods. Technological advancements continue to revolutionize the whipped cream industry. Automation streamlines production lines, enabling faster throughput while maintaining exceptional quality. Artificial intelligence and machine learning algorithms optimize processes by predicting equipment maintenance needs, identifying inefficiencies, and suggesting improvements. Robotics handle repetitive tasks with unmatched precision, freeing human workers to focus on higher value activities. These innovations not only boost productivity, but also allow factories to respond swiftly to changing market demands. Consumer trends heavily influence the evolution of whipped cream production. With increasing awareness about nutrition and wellness, there is a growing interest in healthier alternatives and transparent labeling. Manufacturers address these concerns by developing innovative formulations and providing detailed information about ingredient origins and production methods. Customization capabilities enable factories to produce niche products catering to regional preferences or emerging dietary fads, such as keto-friendly or gluten-free options. Global trade dynamics also shape the way whipped cream is manufactured. Export markets demand adherence to diverse regulatory frameworks, requiring factories to implement flexible systems capable of meeting varying international standards. Collaboration with suppliers, distributors, and retailers ensures alignment with global supply chains, facilitating timely delivery of products worldwide. Continuous investment in research and development keeps factories at the forefront of technological innovation, ensuring their competitiveness in an ever-evolving marketplace. Beyond the technical aspects of production, the cultural significance of whipped cream cannot be overlooked. In many regions, it is more than just a topping. It is a symbol of indulgence and celebration. From birthday cakes to holiday feasts, whipped cream serves as a versatile ingredient that enhances countless dishes. Its widespread popularity has driven manufacturers to explore new applications and presentations, expanding its appeal beyond traditional boundaries. Factories also prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control. Point systems identify potential hazards and establish measures to prevent them. Regular audits and certifications ensure compliance with local and international regulations. Employee training programs emphasize hygiene practices and proper handling procedures, reinforcing a culture of safety throughout the organization. Packaging design plays a vital role in the marketing and distribution of whipped cream. Modern factories invest heavily in developing attractive and functional packaging solutions that appeal to consumers while protecting the product. Innovations in material science have led to the creation of lightweight yet durable containers that reduce shipping costs and environmental impact. Resealable caps and ergonomic handles enhance user convenience, making it easier for customers to enjoy the product without compromising freshness. Supply chain management is another critical component of successful whipped cream production. Efficient logistics ensure a steady flow of raw materials into the factory and finished goods out to retailers. Strategic partnerships with suppliers help secure reliable sources of high-quality cream, while relationships with distributors facilitate rapid delivery to diverse markets. Real-time data analytics enable factories to forecast demand accurately, optimizing inventory levels and reducing waste. Research and development remain central to the growth of the whipped cream industry. Scientists and engineers continuously experiment with new formulations, processing techniques, and packaging technologies to improve product quality and sustainability. Emerging trends in biotechnology and fermentation offer promising avenues for enhancing flavor profiles and extending shelf life. Collaborations with academic institutions and research organizations provide valuable insights into cutting-edge developments that can be applied to commercial production. The economic impact of whipped cream production extends far beyond the factory floor. It supports jobs in agriculture, transportation, retail, and related industries, contributing significantly to local and national economies. By investing in community initiatives and sustainable practices, manufacturers demonstrate their commitment to corporate responsibility and long-term viability. Programs aimed at reducing carbon footprints, conserving water, and promoting biodiversity align with broader societal goals of environmental stewardship. As consumer preferences evolve, so too does the nature of whipped cream production. Health-conscious individuals seek products with fewer additives and artificial ingredients, driving manufacturers to adopt cleaner label approaches. Clear communication about ingredient sourcing and production methods builds trust and fosters loyalty among discerning customers. Educational campaigns highlighting the benefits of whipped cream as part of a balanced diet further reinforce its position as a staple in kitchens worldwide. Finally, the future of whipped cream production promises exciting possibilities. Advances in automation, digitalization, and artificial intelligence will likely transform traditional manufacturing processes, enabling greater efficiency and flexibility. Personalized nutrition platforms may one day allow consumers to customize their own whipped cream blends based on individual dietary needs and preferences. Meanwhile, ongoing efforts to reduce environmental impact and promote social responsibility will ensure that whipped cream remains a beloved and sustainable choice for generations to come. Through precise control of every stage, from cream procurement to final packaging, factories ensure that each container of whipped cream delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind the seemingly straightforward process of making whipped cream, highlighting the dedication and expertise required to bring this indispensable product to tables everywhere. Honey, often called nature's golden nectar, offers more than just sweetness. It nourishes the body with its rich nutritional properties. In this video, we'll explore a traditional bulk honey harvesting process that's both fascinating and meticulous. Stick around, or those stingy honeybees might come for you. When a bee egg hatches, the hive comes alive. A legless, featureless grub resembling a gummy worm emerges. These grubs thrive in hexagonal wax cells that not only protect them, but also store essential food reserves for winter and maintain the hive's temperature and structure. Bees flutter from flower to flower, using their black tongues to gather nectar from blossoms. This nectar is stored in their honey stomach, separate from their digestive system. Harvesting this treasure demands careful preparation. Enter the beekeeper, clad in protective gear and armed with tools like a hive tool and a gentle bee brush. Smoke calms the bees, ensuring an efficient and respectful harvest. The hive frames are separated, brushed free of bees, and transferred into neatly arranged boxes. The hive tool is vital for separating the frames, while a gentle bee brush is used to handle the bees without harming them. Each hive is carefully examined, with the honey-filled frames separated and skillfully transferred to neatly arranged boxes. Watching this, you'll admire one fearless woman who harvests honey without any protective gear at all, something most of us wouldn't dream of trying. The honey hive boxes are now transported to the factory, where they are systematically moved through the first step of processing, removing the top layer of the hive. This natural and magical goodness is packed with rare benefits that will transform your healthy eating plans. Stick around, I'll tell you more in a moment. This process is all done with the help of some common machinery. First, the honeycombs are set, and the machine removes the outer top layer from both sides of the honeycombs, maintaining its pure golden honey. This step is crucial to access the honey, as it's not easy to extract because of the bees' creativity. The boxes begin to release honey at some points, but the major quantity remains inside the combs, which are transported to further processing machines. One by one, each honeycomb tray is placed inside the machine to open the hives and access all the honey the bees were hiding. Then comes the spinning machine, which extracts every drop of honey and transfers it into collectors. I once witnessed a similar rare spinner in Turkey, the second largest producer of pure honey. The spinning process extracts the last drops of honey and thoroughly cleans the hives, making them ready for reuse. The mixed honey is churned a little and passed through built-in sieves, resulting in pure, golden, flawless honey. Next, the honey is stored in large containers at an optimal temperature to maintain fluidity for pouring. The process begins with an automated filling machine. The jars are aligned under a filling nozzle to get the desired amount with minimal spillage or waste. At the sealing station, automated arms place lids on the jars, ensuring everything runs smoothly thanks to automation. Consuming a spoonful of honey before meals can soothe the stomach and improve digestion with its enzymes and antioxidants. Stay healthy and enjoy this natural nectar. You're now inside a honey spoon factory where they handpick the best honey for its amazing flavor. They don't just stop at regular spoons. They mold honey into cute spoon shapes using plastic or silicone. Each spoon gets sealed up tight with fancy film or foil, like wrapping a little gift, so you only grab, unpack, and use the honey without creating any mess. They pack them up in boxes or trays, ensuring each spoon travels safely until it reaches your kitchen. Liquid jam and biscuits create a delicious duo that's both flavorful and wholesome. The natural sweetness of jams enhances the taste of biscuits, adding a rich caramel-like depth that perfectly complements their crunchiness. Need something savory and crispy after a sweet treat? Look at these delicious sandwiches being prepared in no time. Say cheese slice and consider it all done. Donut cakes are the ultimate versatile treat, enjoyed in so many ways. They kickstart mornings perfectly with coffee or tea, adding a sweet touch to breakfast. They're also the go-to for satisfying sweet cravings anytime. Whether you love cream-topped sponge cakes or thoroughly chocolate-dipped donuts, you've got it all. And we don't need to exaggerate the appeal of chocolate dripping. It's anyone's first pure love. Nobody's going to disagree, right? Hey buddies, welcome to the inside scenes of some bulk fruit factories. Let's see how they process and handle so much bulking. First, some good factories use common food sanitizers to clean the water and fruits from outside. Chlorine, the real MVP, gets rid of nasty bacteria, viruses, and fungi. Sometimes they add citric acid to balance the water's pH and make the sanitizers work even better. After a good rinse, the pineapples ride the conveyor belt for a quick dry. Check out those blades. They are going to peel the pineapples like pros. A machine pushes the tough core out of the way, and then skilled workers cut the fruit into the sizes customers want. After slicing, a little but quick bath is necessary. The conveyor belts give the fruit a gentle shake to remove extra moisture without messing up its texture. Finally, they use moderate air pressure to ensure all moisture is gone, keeping the fruit fresh and extending its shelf life. If you're curious about why they fuss so much about keeping fruit dry before packaging, it's quite obvious. Moisture isn't just about making fruit soggy, it disrupts the osmotic balance within fruit tissues, breaking down cell membranes and causing unwanted degradations. After the pineapple chunk's frozen adventure, you'll see a new fluffing technique that separates each chunk, giving it its own uniqueness. Come around, you all raspberry lovers. You're going to witness the largest harvesting and freezing of raspberries you have ever seen. Using fruit, harvesters like these beasts for picking berries in the fields offers significant advantages to fruit processing factories and labor. These machines promise efficiency but demand a skilled touch. Therefore, workers undergo specialized training to navigate the complexities of this crucial job. These machines struggle with selective harvesting and can sometimes result in picking some unripped berries as well. But with the help of the experts, no ruined berry is going to pass through. As soon as the raspberries arrive in the facilities first, the experts carefully remove the ruined berries, and then they get a thorough rinse to get rid of any dirt or germs. After that, they go on the conveyor belt to dry off properly and are frozen right away. Here, the same separating techniques are applied to the frozen raspberries, so they do not stick to each other or make a cluster. These belts have thorough vibrators to fluff the berries. All together, and look, every berry is seen as an individual pack of deliciousness. If it seems satisfying to you and that's your vibe, we can be best friends because we are dedicated to show you the bulk factory processes. Want to stick together? Come on, subscribe to our channel and hit that notification bell to keep watching our upcoming videos. Some people still chose to go for old school methods for some delicate tasks, like picking fruit from trees so they won't get damaged. Their struggle leads them to transport the entire fresh stock of these fruits towards the facilities for further processing. Skilled workers use sharp knives to carefully cut open durian fruit as they are thoroughly cleaned. Again, these workers beautifully collect the inner edible flesh of the fruit in separate baskets. And here, a high-tech refractometer is used to measure the fruit's sweetness to make sure it's just right. As soon as the fruit pulp freezes at the right temperature, a bunch of workers get their gloves on to chop them into equal and smaller chunks. Now the fruit chunks are going in the freezers again to get the required consistency. Have you ever tried durian chips? They are quite famous in Thailand and Malaysia. I haven't tried yet, but I would like to give them a try. Look at that creamy yellow batter. It's going to cover the entire durian chunks. This is going to make the durian even more delicious. Some people often call it the king of fruits because of its rich custard-like texture and sweet, slightly nutty taste. A few people love it for its exotic flavor, while others find it unforgettable. After a thorough drying, the durian chunks are packed into small trays for easy and perfect serving. Did you ever notice how new harvesting machines are making big money for businesses? These high-tech tools are cutting down on labor costs, speeding up the harvesting process, and ensuring the fruit is of really high quality. They're also super accurate, which means less waste, and they're better for the environment. These machines are designed to move smoothly through the fields, gently shaking the bushes to release the ripe blueberries. As the blueberries fall off, the harvester's high-speed conveyor belts collect them efficiently. Each day, these machines can pick tons of blueberries, covering a large area much faster than manual picking. This efficiency not only speeds up the harvesting process, but also ensures the berries are collected at their peak ripeness. Such modern machines also help maintain the quality of the blueberries, ensuring they reach consumers fresh and delicious. Now, these carriers are going to take them with full responsibility and care to the washing facility. So, we are here in this massive, bustling factory where handling heaps of berries is an effortless breeze made possible only by cutting-edge technology. Now, we'll let these berries get a much-needed, thorough wash. Even the laziest bunch will be amazed by the incredible benefits of these purple powerhouses. These berries can supercharge brain function and memory, keeping your mind sharp and focused. These folks are donned in gloves as they expertly sort through the berries, swiftly sidelining any damaged ones. Freezing berries before packaging maintains their nutritional value, ensuring you get all the health benefits as if they were freshly picked. Every time we open a can or packet of frozen berries, we will be amazed by the quality fruit inside and thank them. Look at those experts tirelessly working and sorting these blueberries at different stages to give us the best experience. Did you know there are over 1,000 varieties of mangoes worldwide? That's right, and I know nothing about them. Just eating sweet mangoes is enough for me. These skilled workers use specialized blade cutters to carve mangoes into precise segments. Then, a refreshing bath ensures that any remaining latex from the peel, which can cause irritation or allergic reactions, is thoroughly cleaned off. These cutters transform the mangoes into bite-sized pieces, ensuring you get the full enjoyment of every juicy morsel without any hassle. This conveyor belt is equipped with vibrations, and there's a solid reason behind it. It ensures that any lingering water droplets are completely dried off, while the continuous shaking keeps them separated from each other. Now, they are being flash frozen in giant freezers to lock in all that incredible freshness. As they are carefully packaged into large boxes, workers keep an eagle eye, ensuring each box is filled to perfection. Peaches. Only high-quality peaches are selected for their cut in factories precisely. Their superior quality means better preservation. So, in this esteemed factory, things get started by removing the tough pit from inside the peaches. Razor-sharp precision blades skillfully transform these peaches into perfectly sized, small, juicy pieces. Ever wonder why cans are the top choice for preserving peaches? The canning process seals those juicy peaches in an airtight environment, shielding them from pesky, unwanted contaminants. This airtight seal is a game changer, extending the shelf life of peaches to even years without spoilage. While some peaches are chopped into tiny bits and flash frozen to keep them fresh throughout their usage, the vibrations incorporated in freezing help expose more surface area to the cold air, leading to quicker freezing. Also, it keeps the chunks separated from each other. As I keep on telling this, you must take an idea how important bananas are. Did you know that bananas are fantastic for reducing and preventing muscle cramps and spasms? So, if you're hitting the gym or just dealing with those pesky nighttime leg cramps, grabbing a banana can be your secret weapon. Even if it's in the form of banana chips, it's super delicious. Now, the cantaloupe is being expertly peeled by this skilled worker, with every bit of skin carefully removed. With about 90% water content, cantaloupe is an incredibly hydrating fruit, perfect for keeping you refreshed on a hot day. Moreover, it is a fantastic pick if you want to drop weight as well. First, these papayas get a thorough wash, scrubbing off every bit of dirt. Once revealing that luscious fruit inside, the seeds are expertly removed, and with a few swift cuts, the papayas are transformed into perfect, bite-sized pieces. I hope you've enjoyed this video containing dozens of fruits getting bathed, peeled, sorted, and frozen right away. It's also satisfying, no matter if you like these fruits or not. Some people might be allergic to them, but you will agree that watching anything in so much bulk quantity always gives a positive vibe. Ready I am about how those ready meals we pick up at the store are made in factories. Yes, these massive factories buzz with non-stop energy, churning out thousands of meals in mere minutes. It all kicks off with pots filled with just the right amount of top-notch rice. As the water gets added, the pots are sealed up tight, letting the rice soak up the moisture and settle perfectly. Once it's the right time for cooking, the machines gently but firmly hold those pots, turn them upside down to drain off the water using sieves. Now, the fresh water is being added to these pots to cook the rice up to perfect temperature and consistency. A robotic arm snaps the steamer's lid into place, and then these steam cookers roll out, getting seals attached to each pot as they go. Precise temperatures keep things from going wrong, avoiding any overcooking or undercooking. Of course, when the rice is perfectly cooked, robotic arms step in again. They carefully transfer the pots onto rolling iron rods that guide them along the conveyor belt. It's all automated here, with no human hands involved in the cooking process. That is pretty cool, right? Rice is cooked and all set to pour into the trays, so let them fill the hopper first. After rice, crispy chicken pieces are added to the trays to complete the meal box, along with pouring the sauces. Hey, It's not just one sort of meal box being prepped. You will see meal boxes filled with veggies and irresistible gravy. Boxes are filled, so before sealing the meal boxes, they are going to freeze these trays so they will remain fresh, flavorful, and preserved until you hit the store shelf and grab your favorite meal tray. As these trays glide along the conveyor belt to the sealing station, who wants to deal with anything less than 100% hygienic? That's why this sealing station is spotless, with super strict cleaning routines to keep every seal perfect and free from any contaminants. Now, these meal trays are all decked out in their perfect wrap and sealed tight. Of course, after sealing, the trays roll over to the labeling station where they get tagged with all the key details like brand name, ingredients, and expiry dates. Once these boxes are packed to perfection, this last stop ensures each box is tightly sealed and ready to roll out. I am sure that my fitness enthusiasts are eager to witness how their daily salad trays are crafted in factories. Pile on a generous serving of fresh green veggies, keeping everything perfectly separated. Tender grilled meat slices are added too, taking the game to the next level. And since healthy eats can't skip eggs, they're added as well. These machines portion out spaghetti into trays, giving each one just the perfect quantity. Then the trays cruise down the conveyor belt to the sauce station, where machines drizzle a rich tomato-based sauce all over the spaghetti, making sure each tray gets a big splash. Before we get into how your favorite crunchy banana chips are made, check out how these workers are sorting them to make sure every banana stays top-notch. When the bananas roll in on conveyor belts, they are peeled efficiently without damaging that delicate, crucial part. Why go for green bananas instead of ripe ones? If this ever clicks for you, it's pretty straightforward. Unripe bananas have a firmer texture and less sugar, which gives the chips that perfect crunch. Now, these peeled bananas get sliced into thin, even pieces by these incredible slicing machines. After a wash bath, these slices are checked to make sure they're just the right thickness. The hot oil makes them crunchy and delicious, and of course, the crew rocks face masks and gloves to stay safe. The chips hit another conveyor belt to drain off excess oil and dry out, making them extra crispy. Once dried, the chips get seasoned with their tasty signature flavors, ensuring every chip is perfectly seasoned. Of course, any overcooked chips are sorted out to keep your snack game strong. Finally, the chips get sorted into perfect portions by this huge, high-tech portioning machine. This fascinating machine makes sure every packet has just the right amount. After savoring those hearty meals, don't you think it's time for something sweet to wrap things up? The filling we all love with every crunchy bite starts with some secret ingredients mixing up in this huge machine, where sugar, coconut, and creamy butter team up to create that unbeatable flavor. Once the thick mixture is ready, it gets sliced into perfect pieces by these high-tech blades. It's time for the real treat, These bars are about to take a dip in a rich, flowing chocolate waterfall. And of course, it's crucial to take notes to make sure everything's on point. The chocolate coats each bar just perfectly, giving it that glossy, mouth-watering finish we just can't get over. This is exactly where they get their irresistible chocolatey vibe. So, after their chocolatey bath, they glide through a drying tunnel where some cool air helps the chocolate set, creating a crispy, delicious shell.